Hello, everyone, and welcome to our afternoon session. I hope you had a good lunch break. You had some time to eat, talk, discuss, network, and you're all now fresh and energized for the afternoon session. We will now go to our second panel of the day, and with a clear, kind of very important topic, which is of transmission. And for this, we have Simons, who she's going to be the moderator of the panel. Sorry, the house is an experienced strategic commercial general onboarding connections at the Australian energy market operator. In her role, Siham is responsible for the strategic management of the end-to-end of participants in the national electricity market and the wholesale and retail gas markets. This includes oversight of the NEM connections process and the registration processes for all new market participants. Over to you.
Great, thank you. So the topic that we're discussing today centres around really transmission system operators and our ability and really the industry's ability to enable the future energy system. So I'll do a short introduction first, and we have a bit of a hybrid panel today. So we've got a couple of people, hopefully we can see them on the screen. I can't see them yet. Oh, there they are, that's wonderful. Okay, so I'll do the introduction. I'll start with the virtual and the person waving, Stuart Bell. So Stuart Bell is the Executive General Manager and Business Development at PowerLink in Queensland. He joins us from Queensland today. Stuart has broad experience in all aspects of the electricity industry, including corporate strategy, network planning, project delivery, and network operations. And he's got nearly 20 years senior management experience, and 8 years of those have been at the executive level. So welcome, Stuart. The other person joining us on the screen today is Nikitan Tyagi, who's just waved now. Thanks, Nick, also known as Nick. So we'll call you that today, if that's all right, Nick. So Nick is the Manager of Connections for Electronet and is joining us from South Australia. Nick has been at Electronet for over 4 years, and his role is in new connections and focuses on working with the customer to support the journey of their project and commercial and contractual negotiations. Before joining Electronet, Nick worked in oil and gas for 13 years in Australia. I think we've got Bess is maybe early on the screen. So we might, Bess is not on this panel. So joining a bit early. Maybe she's on NEM time. All right. All right, we're good. I'll introduce the two panel members here in the room. So we have first Damien Sanford, just on my far left. So Damien is the GM of Asset and Digital Services at AusNet Services. Damien joined AusNet Services in March 2020 from AEMO, where he was the Chief Operations Officer. So over the past 10 years, Damien has been pivotal in shaping and operating the national electricity grid, Victorian gas transmission system, and electricity and gas markets in Australia. As part of AusNet Services Growth and Future Networks Division, Damien is now focused on delivering major infrastructure projects, including wind and solar, grid scale connection assets. I think there's also storage in there as well, and the new Victorian Western Transmission System in support of Australia's transition to a sustainable energy future. And finally, we have Nigel Buchanan, and Nigel is the Head of Infrastructure at Lumea and is responsible for organisational strategy, leading teams responsible for the investment and development of a variety of renewable energy assets. His professional and empathetic approach to commercial negotiations, oh, we got someone back on the screen, okay, is informed by over 20 years experience in consulting, business development and leadership within the large-scale infrastructure industry. So welcome to all the panel members. Haven't done this before virtually, where we've got a few people on screen, so I'll make sure Stuart and Nick that I direct questions to you when they come up. We'll kick off with the first question. but I'll start with some context. So as we all know, Australia is currently experiencing the world's fastest energy transition to renewables. Right now, there's more than 340 grid scale connection projects in the pipeline to be connected to the national electricity market. These are mainly wind, solar, and battery storage projects. These projects add up to more than 80 gigawatts of energy installed capacity. And so when we think about on top of the 50 gigawatts that's already installed in the NEM, it's another NEM and a half thereabouts. And they represent the and wind projects constitute more than 30% of the new generation in capacity. So whilst there's a lower number of projects, there's certainly larger projects in the wind space. So I'll start my first question. Maybe Nick, I'll throw over to you for the first question, if that's all right. Sure. With all this new capacity to bring into the grid, and it's the predominantly asynchronous generation, issues such as congestion, system strength, and transmission loss factors will need to be overcome to enable this generation to be connected. What are and can transmission network service providers do to facilitate a smoother connection process?
Sure. No, thanks, Shane. From our perspective, as you know, we are already in the process of upgrading few lines and also have installed the synchronous condensers recently, which were commissioned mid-2021. But then obviously we were also the first ones to retire a coal-fired generator, Northern Power Station, in the 2016. And since then, the two synchronous condensers at Robertstown and the other two at Devonport were installed and commissioned. And as we are starting to see now that since the commissioning of these synchronous condensers, we have actually allowed for conventional generation in the minimum times of minimum conventional generation in South Australia to be increased from 2,000 megawatts to 2,500 megawatts for the non-synchronous generation, which we have just mentioned, which are looking to connect into the NEM. And that is one of the aspects of some of the things we are looking to do in the future. Also part of the, as you mentioned, there's obviously network congestion, not only in South Australia, but NEM-wide. So as part of that, we are also working on upgrading the Eyre Peninsula link, as you may or may not be aware of. But then that project involves the replacement of the existing 132 kV line between Kaltana and Port Lincoln with a new double circuit line between Kaltana and Yadneri, and then that will be initially energized to 132 kV, but in future, depending on how much generation or load looks to connect into that part of the network, will have the option to be operational at 275 kV network, and it will allow for additional generation and load to be connected into that part of the network. Also, the other bit which everyone is aware of, the Project Energy Connect, will allow to release some of this congestion as well. Once fully commissioned, it will allow for additional 800 megawatts to be sent through to New South Wales, or vice versa from New South Wales to South Australia. So these are some of the projects which are already happening, and the synchronous condensers, as I mentioned, has already been commissioned. Will allow for all these additional electrons to flow through, hopefully without much of a hassle, which we are seeing currently with the congestion issues and the system strength challenges we are seeing in the network. Apart from that, we are also investigating ways to further increase the transfer capability between the Southeast region and the Adelaide metropolitan region. And as most of the wind guys would be aware, Southeast region is good from a wind perspective as well, and we are looking to see if we can increase the transfer capability between the Southeast region and Adelaide metropolitan area.
Thanks, Nick. A related question, Stuart, just building on what Nick's already talked through. We know projects can experience an impact on their timelines due to delays in system strength remediation or even connection work, and on generation and commissioning testing due to network constraints. What's PowerLink doing to help connecting participants, and how can these issues be addressed?
Good afternoon, everybody, and apologies I can't be down with you this afternoon, but rest assured the Queensland borders will be opening next week to tell me. So Yep, so you're very welcome to join me in Queensland next week. So system strength, yep, it certainly was a challenge for us. If we go back 3 or 4 years ago, the sheer volume of connections we had at the time, the PS-CAD models that we had ourselves, the PS-CAD models that the inverter manufacturers had were all challenges. But now we've actually got a very functional and very robust PS-CAD model, which looks the whole of Queensland and New South Wales. And that allows us to very quickly now go through the connection process and help pinpoint where, say, inverter models need to be improved. So that's a huge step change from where we were probably 3 or 4 years ago. The other things we've been doing is system strength as a service, and really looking at how we can unlock the economies of scale that you can get through a synchronous condenser. So a number of generators were looking at system strength, and we looked at a way of packaging that up to then, they say, putting in a large synchronous condenser and only selling part of it to generator connections. And we're still open to that should people require system strength. And that's really being leveraged on now as part of the new system strength rule change as well, where really that kind of economies of scale. So in future years, then the networks will then develop that and then sell the portion back to the generator connection. So very, very active in that space. The tuning, so we had a system strength shortfall up in far north Queensland last year, and one option was to put in a synchronous condenser, but using the models we've now got, we actually found that we could resolve the issue by tuning the wind farm inverters and 3 solar farm inverters in far north Queensland. So again, it's just the inverter tuning's one aspect. You can that stops the inverters talking to each other and getting confused during fault conditions. We'll also need system strength, and whether that comes from a synchronous condenser or some other form in the future, such as batteries, is another thing that we're actively looking at. And then similarly, once you're actually connected, we're looking at some novel ways now to minimize any impacts on network outages on generation. And that's something that we're evolving over the next few months. So again, that's to, once you are connected, to actually minimize any impact. Thanks,
Stuart. Probably a related question for Damien. It's a little bit off script, Damien, I apologise. But in a panel discussion earlier today, there was a concern around the timeframes to take to build new infrastructure and to get regulatory approvals for new assets and new lines. And given that that is certainly part of the solution to enable more generation to connect in where it's wanting to connect, what do you think can be done in addition to that to help facilitate more renewables? I mean, Stuart talked about, plant inverter tuning, and of course that is absolutely available, and we are all looking at that and using it. What else do you think from your experience? And I think also drawing on your AEMO experience previously.
I think it's a really good question. I think the first thing we need to do is to start modelling the power system without coal on it. So if you have a look at every publication we put out there, it currently still has coal being dispatched. And if you think about the electrical properties that coal brings to the table, the system strength, the voltage control, then once that's gone, it's going to have to be replaced. And so I think if you think about building these massive wind farms and think about what the system's going to look like over the next 30 years and start to put that kit in the ground now, you'll probably get a better outcome.
Thank you. All right. One of the other things that we've certainly seen develop in the industry, and we talked about again this morning, was the renewable energy zones. And many of the jurisdictions, the various NEM state governments have and are establishing their own renewable energy zones, and each with their own new approach to the coordination and development of these RESs, including the coordination of generation connections within these RESs. This one's a question for you, Nigel, particularly in the New South Wales context. But what do you think are the benefits and challenges for projects connecting into a RES, noting that they do have different approaches?
Yeah, it's a really interesting and complex question, and it probably links into some of what the other panelists have already said. You know, there's a range of things we're talking about here. One's the immediate tuning and things Lumia and Transgrid are doing similarly to get the existing connections on. I think Damien's right. The long-term solution needs to contemplate modelling without coal. But the other piece that is happening across all states, and obviously New South Wales is currently at the forefront of that, is the development of RES and hybrid regulation and legal structures. New South Wales obviously is charging ahead with the RESs. You're seeing testability introduced into New South Wales. New England RES is going to be contestable. The challenge with that process is it will help with renewable connections. It gives direction, it gives scales, it gives the ability to forward plan. I think the piece that we haven't quite worked out across the RESs nationally is what the right allocation of risk and reward is commercially. Each of the models is slightly different. Through Lumia, we've won work in the Victorian model around contestability. We're now looking at the New South Wales model, and I think there are still some iterations to go around regulatory alignment on that. I mean, to be fair, and I have to say this, I think it's a massive step forward. If you look at New South Wales from 3 or 4 years ago, the fact that we can have a conversation about the tweaking of the models is a massive step forward. But there's no question that the way the LTESA works and the way the contestability of the enabling infrastructure coincides with that will make the difference between whether we're successful or not. And I think Damien makes a great point that part of that solution is being clear about what the long-term future is versus the short-term solution for the immediate problem. And that needs to tie into the coal retirement. You've touched on there's a massive issue coming when certain plants come out if we haven't planned for those retirements for the services that coal provides naturally, and which this new generation system doesn't. One of the, I guess, key points I see in that is, to use a parallel, is yesterday some legislation went through New South Wales Parliament. Who pays what's in charges? There's some exemptions in that legislation for a particular type of technology, specifically hydrogen. We seem to be going the other way with batteries in the national system. And until we get that alignment sorted out, it's going to be a bit clunky. But I guess like all transition, as we've seen with people being on Zoom, there is a bit of clunk we've all got to work through together. So that's probably where I'd start that conversation.
Thanks, Nigel. Stuart, wouldn't mind your thoughts on this in terms of what's happening in Queensland around the RES developments as well?
So fundamentally, I think RESs are a great idea. The concept really is to flag where different parts of the network, either it's networks very strong or the weather patterns, wind patterns are different, which allows basically a better path to market for the generators. So I think they're great signposts these are areas where you need where you should to generate. We're working very closely with the Queensland government here, looking at RESs, and at our Powerlink forum last month, there was joint forums presented by Powerlink and the Queensland government on the RES concepts. We're looking at RESs in both North Queensland, Central Queensland and Southern Queensland. And the Queensland government's got a technical paper out at the moment with their kind of RES architecture. So if anybody's got some ideas and thoughts, then please put a submission in back to the Queensland government. We've also been active in Queensland, so we've actually got a far north Queensland RES, which is under development at the moment. So in this case, earlier about January this year, there was a wind farm looking to connect, and they actually required some system strength, and we were looking at a synchronous condenser for them. With having the planners working for me as well as the business development part, the planners came up with a clever solution, and they said, well, we could actually augment and raise the voltage of one of the circuits in far north Queensland from 132 to 275. That would provide them system strength, which allow the generator to connect. It would improve the resilience to load in cairns. It would actually also increase the hosting capacity in North Queensland to about 500 megawatts, and there's some nice wind up in far North Queensland, which we'd like to get our hands on. So we managed to negotiate with the wind farm developer, with the Queensland government, and also a contribution from the regulatory part of the business to actually upgrade that line from 132 to 275. Now, if we try to do that individually, it wouldn't have worked. The wind farm developer couldn't have paid the whole amount. the regulatory part of the business couldn't have paid that whole amount, and similar with the government. So, but by working in partnership across those three lines of business, we managed to find a solution, and we're now transformers have been ordered, and we'll be upgrading that line next year. So that's a good news story up there. And as I say, fundamentally, reses are good signposts, or where the network is particularly strong, or where the wind patterns are different, say, to solar. And one thing I've noticed, and as a wind conference, and is we've got about 4.5 gig either or under construction here in Queensland. 3,500 gigawatts is solar, and about gigawatts either pump storage or wind. And ideally, we would like to have something like 6 or 7 parts wind and 3 parts solar. At the moment, we've got 9 parts solar and 1 part wind. So that's why I'm here this afternoon. I'm very keen to see more wind head north to Queensland.
You got the resources for it?
There's wind resources.
Yeah, wind resources.
Oh yes, we've got some nice wind here in Queensland.
Thanks, Stuart. Just building on that, and again, Damien, I apologise. I'm going to throw another question to you, but Victoria is quite attractive in terms of its wind resources, and certainly the Victorian government is quite keen and has put plans in place in terms of developing renewable energy zones. From a Victorian context, what do you think are the biggest challenges or opportunities in relation to being able to connect more wind into those reses?
I think from a Victorian perspective, we're out of grid. It's full. And, I know we publish reports that say there's 4,000 megawatts of capacity, and that might be from a thermal perspective, but it can't be operated when you got things like outages and stuff that needs to occur. So unless we build more transmission, I'm going to have to come and play in Nigel's patch in New South Wales to chase down projects. In terms of considerations, I think we need to think about what that future design for those large wind farms in particular needs to look like. Where they're located, the diversification of that resource compared to what's already in there. If you think about Victoria's energy system, the wind comes from the west, and on those hot summer days comes from the southwest, and it swings through, and all that wind in the southwest gets a big peak on the energy output, and then it falls away really quickly, sometimes 1,000 megawatts over an hour. And so I think where we're siting these large wind farms, we need to think about that. You don't want all your eggs on one basket as the next system operator. I can tell you, ringing the minister and tell her you're running out of energy, even though you've got 15 gigawatts of generation, is not a good call. I think, as I said before, we need to think about coal, so in our considerations. And we've done some modelling at AusNet, and there'll be more come out on this early next year. But our view is all coal in Victoria is gone by 2035. Doesn't matter what the reason is, could be economic, could be social considerations, could be end of technical life. But if you work on the assumption it's gone by 2035, then you need to plan your connections and your wind farms around what it looks like without that coal online. And what I mean by that is no system strength, the voltage control disappears, there are peak demand limitations and flows across V&I that you really need to think about. And I think there's a role for organisations like AEMO and networks to be putting that information out there ahead of time, because you don't need sophisticated PSCAD models to realise that if you put 2 gigawatts of plant in one part of the network, you're going to have a voltage collapse issue. Or you take all the coal out, you're going to have no system strength and it needs to be replaced. And we need to start to put that information out there now to allow developers to think about what their connection needs to look like. That all said, there's heaps of opportunities. I think the price of storage coming down means that firming becomes more attractive to some of these large farms. And if you're operating a grid with zero demand, and we'll be at zero demand probably by about 2025, 26 in Victoria, and poor old Nick in South Australia is already there and probably sweats every time it's a weekend in the shoulder season, then we need more storage, because we're going to produce renewable energy at those times when we don't need it. And so thinking about hybrid models for our wind farms and what that might mean from how they play in the market, whether it be as a scheduled generator rather than semi-scheduled, is probably some considerations and probably some points for innovation there. I think some of the challenges going forward, getting coordinated infrastructure, and it's really pleasing to see in Victoria, the Minister talking this morning about the 3 offshore wind farms that they've given some funding to further their environmental studies. But aggregate that up, that's about 4.7 gigawatts of wind all coming from the southeast off the Bass or Gippsland coast. Now, if you think about each one of them trying to have its private connection up to either Loy Yang or Hazelwood, plus Marinus Link, plus Bass Link, that's a lot of infrastructure in down in the Gippsland region. How do we get better coordination across that infrastructure? Who takes the risk on building that? Because we all know the current reg regime only allows us to consider unlocking congestion, not prospective infrastructure development. And so similar to New South Wales, we probably need to get a bit of a giddy up here in Victoria to build out that infrastructure to allow that development to go ahead. The last one that we're thinking really heavily about, particularly an offshore wind industry in Victoria, and we're very bullish on the offshore wind industry because if you map Victoria and what it needs once you shut all the coal, it's about another 14 gigawatts of grid scale wind and solar and about 6 gigawatts of storage you need, right? And that's spread across all those reses. When you map the land constraints and the social license issues around where you can build that stuff, there's not a lot of land in Victoria. In fact, it's the most populated state in Victoria compared to New South Wales, 4 times more populated for the land area. And so you very quickly get forced to offshore wind. But the key infrastructure you need that is a maritime infrastructure. And so one of the things we need to start to look at as an industry, and I know Vic government are looking at this, is what is needed as an industry to get that away. And there's about 20 ships globally that can build offshore wind farms at the moment. And we're not the only country looking at this. So we need to think where our investment dollars go to enable that infrastructure going forward.
Thanks, Damien. There was a lot in there. I might see if there's any questions now before I continue on with the other questions we have. Yep, just in the back there. Nick, did you hear that question?
I didn't get anything.
You didn't
Sorry.
hear anything. Okay, we might just get a microphone, just one moment, and ask you to please repeat that question. It was around the transfer capability for PEC, for Project Energy Connect, 1100 meg versus 800 meg.
Yeah, this was for Nick. I think you said it was Project Energy Connect would have 11 gigawatts coming from South Australia, and I've only ever read 800 as the figure. So could you please clarify that?
Yeah, that probably was the microphone because I did say 800 megawatts. So your information is correct.
That was an easy answer. All right. Are there any other questions? Yep, we have a question just out the front there.
Okay, it's Bruce Miller from Shell Energy. Can we just unpack what system strength is to the panel? It seems to be a catch-all phrase to me. I'd just like to understand what the panel thinks system strength actually is.
Engineering exam question, Stuart, do you want to go first? and then Damien, and yes, Nigel is not an engineer, so we won't ask you.
Yeah. I was going to say, Nigel, he's perfect for this. So to me, it's really about the voltage waveform. And one of the things that I think about is when you actually have a fault in the network, then the waveform gets a bit distorted. The challenge we have with the inverters we've got at the moment, they're all grid following. So when the voltage waveform gets a little bit out of shape, all the inverters in Queensland follow that weird shape and reinforce it until the equivalent of the synchronous generators all pull it back into a nice 50 hertz sinusoid waveform. So that's in my simplistic terms is what I'm thinking, is that you need a certain amount of that spinning inertia and capacity from those generators to really pull that voltage waveform back into its 50 hertz. If you get a good forming inverter, then if they can then start forming the 50 hertz cycle after a fault, then I think we'll be in a better position. But at the moment, majority of them are all good at grid following. So when the waveform gets distorted, they follow the distorted waveform. Damien, you can now correct me.
No, you're right, Stuart. Look, it's just the stiffness of the voltage waveform to be able to, manage post-fault conditions. That's it. So,
the non-electrical engineering answer is it's the thing that enables all the power to get across the grid and provide the quality of supply. These people are the experts who will solve that. But it's really important we're able to explain that, because commercially it's about providing those services through hybrid connections and through the way the NSPs behave, and system security and who has allocated the risk for and the reward for it is going to be really critical to that fundamental piece of giving us the quality of supply, which is the 50 hertz thing, and the way we get the power onto the grid in a change power generation. But I have to acknowledge I'm not an electrical engineer, so that's the kind of, from where I work in a commercial business, how we think about it piece. And I think that's probably as important as the technical solution is making sure the allocation of risk and return is right to the parties that are playing in the NEM and the market. And so that's a very non-engineering answer to an engineering question.
And I think I might just add, in terms of the technology and the capability of some of these inverter-based resources and what we're seeing, there is new capability that is coming to the market and is being trialled and is being tested in the form of grid forming, which will support those grid following type technologies that can support some of the issues that we are seeing in the system, and particularly in areas where there is a weak grid or system strength issues. I might just ask, has that sufficiently answered your question?
Bruce can go on all day on this.
Can he? So I shouldn't ask Bruce. I shouldn't ask Bruce if he's. Oh dear.
Yeah, I should have made clear that I am an electrical engineer, so I do understand the technical concepts, but I just wanted to hear what the panel had to say. I don't think we've heard from Nick.
See how I advise you to get control of this panel really quick.
Like Nigel, I'm also not an electrical engineer, but again, I would probably chime into what everyone else have said. Is my understanding so far is that, well, you need to have some sort of conventional generation into the system, and especially in South Australia, as you guys know, we don't have any sort of coal-fired generation anymore. But depending, and IMO obviously instructs all these gas generators to be online for most of the times, and the synchronous condensers I mentioned earlier in my conversation have actually shown us that we don't need the gas generation anymore, to be honest. At the moment, from where we were from 4 gas generators, we are now being instructed to keep 2 gas generators on, because the 4 synchronous condensers we have installed are actually providing us that sort of inertia or system strength requirement.
Okay. Any other questions? Oh, yep, just behind you.
I'm not an electrical engineer, so I won't ask an exam question. You made reference to the, sorry, Bruce. You made reference to the need for a maritime infrastructure for offshore wind. Maritime infrastructure obviously is one part of that. How do you see this being overcome in the short and the medium term?
I think it's going to need some government support to get that up and running, to be honest. And I think that's what governments like Victoria are looking at now. I mean, we're not experts in it. We're starting to learn ourselves around what that looks like. If you think about, say, the value of our transmission networks, probably around $4 billion. The combined investment of those 3 offshore wind farms is probably closer to $20 billion. So understanding that infrastructure is important for us, particularly if we're going to service those customers going forward. But I think it's going to need government support.
And I'll just add that recently there was a federal government legislation that successfully passed that has, through the Senate, that will allow offshore wind farms to be built in Australian waters. So, I mean, that's the first step in this, right? So enabling, but there is the infrastructure aspects of it. All right, any?
Sorry, I was that yes, the infrastructure, the legislation for offshore building is one part of it. But if we look at the European situation and we look at where the Dogger Bank was, and it took 15 years of legislation and infrastructure building, we're a little bit behind that curve. So in addition, where do we see the local construction network being built? Let's just talk about the wind turbine manufacturers and nothing else at this point.
I couldn't agree more with you, but that's really a policy decision. You know, I think we're competing globally for these resources now. If you look at the macro view of what Australia needs, and I think Sihan can talk to this better than I, is probably 100 gigawatts of proposed renewables, maybe 50 of that'll get built, and there's probably $20 billion worth of transmission infrastructure. There's a great opportunity for governments to really think about how they establish local manufacturing and resources to enable that. As network operators, and Lumia and Transgrid and ourselves and Powerlink and Electronet, we'll all go it alone to deliver our individual projects. But there's a real opportunity for harmonisation and volume here to enable Australia to be a powerhouse in that space. But as I said, that's a policy decision.
I can maybe help out with coming from ExxonMobil. I think they've got an offshore industry right there that needs to transition. So that may be an opportunity. Sorry.
Boat for sale, is there?
Yeah. I don't know. So I'm actually at AGL at the moment, Simon Anderson. Had a question around the PS-CAD modelling. I'm not an electrical engineer. I don't have to do it myself, but just a lot of colleagues have a lot of frustration with it. And often you get a notification about system strength and you have to do the modelling, you have to sort it out. I was wondering if there's an opportunity to be a bit more transparent with the modelling that AMO does and transition service providers, so that project proponents, project operators can, I guess, solve it a bit more quickly. So just thoughts on whether we can make that PS-CAD modelling a bit more accessible in future.
I might take that one. I know I'm the moderator, but I will try and answer this one for you. This has always been an issue in terms of transparency of that PS-CAD model, particularly given the confidentiality around the source code and what sits behind the model. And it is accessible to the NSPs at the moment. So all the network service providers do have access to those PS-CAD models, but that's essentially where it stops. We are, as AMO, working on a tool called the Connection Simulator tool that will provide access to all OEMs, proponents, engineering consultants, ability to input your own plant details and then get a response back in terms of how that would be modeled in the back end via AMO. So that will give you, whilst it won't give you access or full visibility to the details within the PS-CAD model, it will allow you to assess your plant, your GPS against what we would use to model, to test that model. So that's an avenue. I think earlier today, Stephen Nethery also mentioned the Connections Reform Initiative work, and that's certainly come up as a pain point within that we've explored some alternative solutions too, including black boxing of models that, you know, we're also having a look at and potentially exploring. But I think there's a couple of options, at least one real one that is being tested right now in a minimum viable product type scenario with a number of OEMs. So we're hopeful that that gives you some access to at least be able to test and see how we might be testing your models against the broader wide area model. I know Damien's got a bit to say about this as well.
I'll try not to go too far off the reservation here. Yeah. I think we've pushed modelling as far as it can be, right? We are modelling the bejesus out of everything, but I'm not sure it actually reflects what's actually going on in the power system today and what I've been advocating for started in my time at AEMO, but more so now with AusNet, is getting more high resolution monitoring onto the grid. I know PowerLink is doing that. Tas Network's already done it. Electronet's putting a few in. Transgrid's probably got a few, and we've got a few to go in. So that allows us to very quickly validate the accuracy of these models. And we all know, models can be up to 20% out. The thermal plant in the Latrobe Valley is not a site-specific PSCAD model. And yet in our distribution network, we will hold to account a 50 megawatt solar farm, on its performance of its PSCAD model for the performance of PowerLink's network at Gladstone. I mean, that is just ridiculous. And so getting more high speed, modeling that AEMO can use, that their control room can use, that we can all use into the developers as well, to say it's an artifact to your modeling or it's a real issue on the grid, is probably where we need to go. So that's probably my view.
Yeah, I tend to agree. And there's probably a combination in terms of where we are today. So we're certainly, as AEMO, looking at better measurement units of physical ones that we can actually then test and validate, right? Some of the things that we're seeing, and particularly in areas where we do have those constraints, where we are seeing system issues. But I think there's a little bit of a journey too when we talk about modelling. The fact is, it's only going to be as good as the information that goes in. And that's why a very important part of it is to actually validate what's been built and do those assessments during the commissioning testing and after the plant is operational. And it's fair to say that historically that the rigour hasn't been fantastic around that. And Damien's right. There are some models that are substandard, that are questionable, and it requires further investigation. When you do have to see what's going on and investigate why that's happening. But at the same time, in the absence of anything else, that is the tool that we have to actually check the operational conditions. So until we have more phaser measurement units out there that can actually validate that, that's the tool, that we are using.
Going off reservation slightly, it leads to an obvious question, because you hear the modelling conversation regularly, but I think the frustration in the whole industry, and I think it's true in the NSPs as much as it is in the developers, is the increasing timeframes and the certainty of investment. I mean, there's at least one project in New South Wales where the technology of the turbines was faster than the development process and the approval process, and so they had to reset the whole investment cycle. So the modelling, to a degree, is a bit of a symptom of not us all working our way through the transition. And so for me, it's about, Lemire and other companies implementing practically the solutions whilst working with the regulators to improve that modelling piece and improving the tools we use, but recognising that, to give you an example, for Lemire and Transgrid, the capital spend on the development, we look at our capital curves as we build the assets to connect. That's drifted out in the last 2 years from a kind of 12-month horizon to 24-month horizon through a combination of challenges in the grid, congestion issues. We've already talked about the volume change. I think you used the phrase 1.5 times the NEM. And so I sometimes think the modelling conversation is important, but there's a higher level regulatory directional piece, industry enablement piece that Damien spoke about that actually requires all of us to work together to solve that. And that's never easy, right? We've all got our own commercial interests. We're all, Damien summed it up pretty well. We'll all go off and do what we need to do as businesses, but there is a real opportunity here to move on from the modelling conversation and move to, we've got a lot to do in the next 10 years. 2035 is almost the fall off the cliff date in all jurisdictions, I think, just about. And so, we're talking timelines of eight years to build these assets. PEC's on the way, it's great, it'll free up capacity. But even when that's built, it's still not really big enough for what's being proposed. And the regulatory framework needs some tweaking to help that process. There's lots happening. Victorian government's getting busy. New South Wales government's already busy. So we've got to support those processes, acknowledging that they will be in places flawed. They won't get it right every time. We won't get it right every time. But the modelling question for me very much is a question about a symptom, not a cause, with the speed with which this transition is happening. And so we're really interested to see how the other panellists think about that. But for me, we need to move on from the modelling conversation.
Maybe we'll hear from an engineer. Stuart, what's your thoughts on that in terms of modelling and how important that is?
Well, it's always a trade-off between speed of connection and keeping the network stable, and it's just trying to find that happy space and where we're all equally uncomfortable and we keep the lights on. The modelling is taking a step change improvement over the years, and we've done testing and comparing it with what we're seeing on the network, and we'll continue to refine that as we go forward. The challenge is if things aren't as we expect in modelling, and results could be positive or they could actually be negative. So the challenge then is when if you say, oh, I don't agree with the models, let's just build it, and then you turn it on and test it, and you go, oh, hang on, then it's not working as we expected. Oh, sorry, you can't generate anymore. Then that would be a very bad outcome. So it's just trying to find that balance.
Yeah, and I can tell you, Nigel, we have had that instance, right, where that's happened, unfortunately.
Don't get me wrong, I did say I was going off reservation. I think it's really important we have the whole conversation. I don't want to give the impression I don't respect the modelling or don't think it's important. It is absolutely critical to keeping the grid up. I just think it's part of a conversation, not the whole conversation.
Yep, agree. All right, are there any other questions? Oh, quite a few. Okay, we'll take your question. We'll just wait for the microphone.
Hi, it's Liam Schwartz from Jacobs. Talked about how Australia is kind of going through the kind of quickest energy transition globally. Also, a lot of countries around the world might be historically been further ahead. So UK and Europe has quite a mature wind market. Has there been any work on trying to understand or trying to take maybe some inspiration and what has worked well in those other countries that are further along in that journey to say, well, you know, this approach to regulation or this approach to the market factors, whatever else, has worked quite well. So we can steal some of the good bits, and here are the things that didn't work so well, and we can get through that kind of transition even quicker in Australia if we take kind of cherry pick those good parts.
Who would like to take a crack at that one?
I'll have a go at that. Look, probably talk more from my previous role at AEMO, where I was fortunate enough to go and do some international travel and have a look at what other grid operators and market operators and regulators were doing around the world. And I turned up at many, both in Europe and the US, probably a dozen in total, and expecting to learn something new. And, you know, the response was, thank God you're here. We're really interested in what you guys are doing in Australia because you guys are crazy. I think there are things that we do learn around places like California, Texas with their wind, and even with their commercial res lines that they built there. The FFR markets out of the UK, we're looking at those in Australia. So I think we're cherry picking the right pieces, but in many respects, if you think about peak demand in the NEM now is about 36 gigawatts on a really hot summer's day. We've got 15 gigawatts of rooftop PV. Like proportionally, there's no other country in the world that is doing that stuff. And so we are at the bleeding edge. And I think many countries look to us to get it right. And I think there will be more speed humps along the way. And so they'll also look at what we get wrong.
Thanks, Damien. I will add, as part of the Connections Reform Initiative, we did do some work around having a look, particularly in the California and Ireland even, around their connection assessment process and how they manage that, where we were getting, large volumes in a concentrated area, a sort of a renewable energy hotspot. And we have looked at some of, the design elements of that might work. But again, the conditions within the national electricity market are a little bit different in terms of the open access regime. And so there's a broader question, which is, I guess, why when we look at New South Wales and what's being proposed there with the renewable energy zones and essentially segment and works, it's made available prior to, accepting is actually not a bad way to plan for it. But yes, I would say it is something that the industry is continuing to look through. Yeah.
And similarly, I would say just reinforce Damien's comments, and I think we've both been involved with Seagrey, and we've been our teams have been out there looking through the world. And again, the feedback is that we're looking at Australia to see how you navigate, so that we can learn from you. And I remember talking with the planning exec at ERCOT in Texas, and some of the challenges they've been having, and we were talking about what they were doing in their networks, and said, "Oh yes, we thought we would put a synchronous condenser in, and that would solve the problem." And they popped it in, and it actually made the problem worse. So anyway, we're learning as best we can from others, but rest assured, a lot of people are watching Australia.
Thanks, Stuart.
Yeah, thanks. Ian Flatley from Groundline. I just wanted a question about marginal loss factors. At the moment, there's like a two-tier sort of economy here. We've got the regulated generators regulated system, and then we've got the unreg. And the ones who come on late seem to be penalised. Want a better word? No, please.
No, look, MLFs is an interesting challenge, and I used to hate summer, finish summer, and go straight into publishing MLFs, and that was just a terrible. Particularly, MLFs aren't that complicated. If you put more generation in a really congested part of the network, you're going to change the MLFs. And I once used, with a banker that was talking about how their financial models were broken due to the MLFs. And I said, well, if you've got 3 branches of a bank, one is at the Docklands, one is at Spring Street, and the other one's at Mildura. And the Spring Street and the Mildura branch have to take $100 million worth of loose cash sitting in an open truck down to the Docklands branch. How much MLFs or how much cash is going to be left by the time they get to the Docklands branch, particularly from Mildura? And he kind of understood MLFs after that. It's just a function of congestion and how much you put in and what your loads are, and they're going to continue to change. And it's not the later ones that are penalised. Quite often, it's the incumbents that get penalised.
All right. Any other questions? Yep.
Hi, my name is Pedro. I work for Divers Earth Moving. We are civil contractor in Goulburn. Lots of bulk haulage and plant equipment, burning diesel every day. I would like to be positive and think that in 10, 15 years, maybe 20 years, will be transition to electrical trucks and plant equipment. My question is if there is any special thoughts around that and the increase of the demand for the electrical cars and vehicles and the planes on top of the grid.
I can, I'll go, Nigel.
So interestingly enough, Transgrid and Lamia actually invested in electrical buses in New South Wales to look into all those things and how it'll affect the grid. I mean, it's a bit of an innovative project to look at that. And so I think the future you're calling for is one that is coming. It's going to be hardest in a heavy plant, I suppose, but absolutely something we're looking at. I can't kind of give you a perfect answer right now because I think it's something that will evolve, but there's no question that the industry is looking at it, wants the same journey and outcome for the full transition. You want everything to be moving to that transition. And so for us, it's very much part of our thinking. Exactly where we will invest and play, we're still working out, but we're starting innovation projects to look at how we can help with that problem. So I'll hand over to Stephen, Stuart, sorry, to provide his input.
So we did a bit of a study looking at the whole energy use within Queensland, and about 25% of it's electricity, about 50% is oil, diesel, petrol, and about 25% is gas. Then as you say, look towards a net zero by 2050, then a lot of that energy will move from oil, petrol, gas to renewable electricity. Now, it doesn't mean that we'll go see a quadrupling of demand over that time period, because what you find is the electrical processes are far more efficient. So an electric car is about 4 times more efficient than a diesel or petrol equivalent. But it's quite feasible that you could see a doubling of electricity demand, and that kind of mirrors some of the scenarios that AEMO's been exploring as part of their ISP. So yeah, so you can certainly see upward pressure on electricity demand into the future. And we've got a particular miner up in Queensland who burns, I think, something like 900,000 litres of diesel a year, and they're looking at opportunities to change their yellow mining Tonka toys into either electric or hydrogen.
Thanks, Stuart. All right, well, we've got just 5 minutes to go, so I might just ask the panel members any final comments or thoughts before we wrap up. I'll start with Damien. I'm looking at him.
I just think, look, yeah, there's such a great opportunity for wind in Australia. We've got some of the best resources, particularly near the coast. I think, you know, understanding what our transmission system needs to look like to support that going forward is where the NSPs and AEMO need to do a little bit more work. And I think if we can get that right, then it's a great opportunity for all renewables going forward.
Thanks, Damien. Nigel?
My final thoughts are great to be in Victoria. I should have said that earlier, being allowed to travel again. So great to be here. In terms of where we're heading, yeah, I'd reiterate Damien's comment. I think there's a great opportunity nationally. Obviously, New South Wales at the moment is very much the centre of things, which is great. So looking forward to seeing you all there. But I think it's going to be a fun journey for all of us for the next decade at least. I'm looking forward to that journey.
Thanks, Nigel. Stuart?
So fundamentally, the energy transformation is not coming, it is actually here, it's underway. We've got lots of renewables in the pipeline, I think about 6.5 gig, I think, in Queensland that we're processing. But fundamentally, my point was that we've currently got about 9 parts solar, 1 part wind. If you want to minimise the storage requirements going forward, you need about 6 or 7 parts wind and 3 parts solar. We're seeing 700 megawatts of rooftop solar going on every year. So certainly see, when you talk about grid connecting, certainly see a lot of wind. The wind future is very bright.
Yep. Thanks, Stuart. Nick?
Yep, thanks. And just to add to that, so I know we all touched base on how good the resources are for wind in Australia, but the reality is we still have to get to the end where the projects gets energized in the time frames everyone is looking for. So just want to lay it out there that all of us, including Transgrid, AusNet, and PowerLink and Electronet, we are all there to support you guys, and we certainly encourage that you guys engage with us as early as possible. When I say early, means even before you choose your OEMs and inverter technologies, please make sure you engage with us. We have a lot of information, as Damien, Nigel, and Stuart also mentioned. We have a lot of information. We obviously look into the future and work through all the network modelings and all those information along with AEMO. And if you are engaging with us, we'll only assist you in choosing the right technology for your projects. So just keep that in mind. And just one last point, although inevitable, please try and avoid making changes once you have submitted the connection application.
Yes, great advice, Nick. We didn't get to talk about that, unfortunately. I didn't do that well at timekeeping, but wonderful advice. There is, as I said, over 30% of the capacity in the current pipeline of connection projects. Wind. I want to thank all the panel members today, particularly those joining us virtually. Thank you all. Appreciate it.
Thank you.
Thank you, Siham, for moderating the session and for the panelists. We'll now move to a very specific, not solution, but a project that we'll discuss that goes along the lines of transmission, the limitations. And we'll have Bress Clark talk about it. Bress Clark is heading TAS Networks project Marinus, developing a second Barra Strait electricity interconnector, the Marinus Link. She's an experienced senior leader with a demonstrated track record in the utilities sector. Skilled in utility networks, major project strategy, energy policy and regulation, governance, and stakeholder relations. The last 8 years, she has been with TAS Networks as a general manager in several fields. Please welcome Bess.
Thank you all very much. I'm back. This time I've done my makeup. I apologise. I've had one of those COVID Zoom moments where you don't realise you're on camera. It is slightly less embarrassing than some of the ones I've seen in the background of some of the meetings I've been in over the last couple of years. So it's fantastic to be here, unfortunately online, but as some others have said, in the next few weeks, we're looking forward to resuming interstate travel, and obviously leading Project Marinus, we're really keen to spend more time in Victoria as we progress this really exciting project. So I'd also just like to recognise that today I'm presenting from the lands of the Muwinina people here in Tasmania, and pay respects to their elders past, present and emerging. So what's Marinus Link? Marinus Link is a proposed 1500 megawatt interconnector between Victoria's Latrobe Valley and Tasmania, connecting into northwest Tasmania. And it's an HVDC interconnector supported by upgrades to the backbone AC transmission network in Tasmania. And together we call Marinus Link the HVDC component and the upgrades to the AC component Project Marinus. And Project Marinus has passed the regulatory investment test for transmission, and AEMO's last ISP included it as an actionable project, and the engagement we've been doing with AEMO on its draft ISP due out this week suggests that it's going to continue to feature really strongly in the national electricity grid of the future. And it's certainly recognised by Infrastructure Australia, Infrastructure Victoria, Infrastructure Tasmania as a key project that provides significant benefits to the energy market and beyond. We have funding support from the Australian and Tasmanian governments that are funding the work to date, and a commitment to fund the project through to a final investment decision. So we're here at a wind conference, and I guess a key feature of Project Marinus and Marinus Link is that it helps to harness Australia's great wind resources. And we've just been hearing from transmission businesses around Australia. And I guess a key thing about wind resource is the diversity of wind. And AEMO has recognised that Tasmania has some of Australia's highest quality wind resources. And I think we've got the highest capacity wind performing wind farm in the NEM. And basically, you know, Tasmania is an island sitting in the roaring 40s with wind coming at it from all directions. So there's really high capacity wind in Tasmania, but it's also complementary with wind elsewhere and wind and solar resources elsewhere. And so from our perspective, we see that Marinus Link allows us to harness that diversity between NEM regions. It also allows us to actually help to plug in some of the wind that's to be developed. So the work on the supporting transmission projects in Tassie, so my team's just playing with the camera. The work on designing the supporting transmission upgrades in northwest Tasmania is ultimately done in a way so that we can move energy to and from Marinus Link, that 1500 megawatts of capacity, but do it in a way that we're optimising the transmission build so that we're also unlocking the northwest renewable energy zone, the potential offshore northwest renewable energy zone, and the central renewable energy zones, which are recognised as really priority zones in Australia, in Tasmania. And in Victoria, we're coming in adjacent to the Gippsland renewable energy zone. And again, we're really complementary with some of the renewable energy resources and also things like battery projects proposed in that region. So we both share resources, but we also provide capacity to connect resources. And in the last session, there was a bit of discussion about, you know, the transforming electricity grid and the fact that losing things like our coal-fired generation over time means we're losing some of the traditional source of system strength, and we're now connecting far more asynchronous connections to our network that are weakening how our power system has traditionally been operated. And so our engineering team is working with manufacturers around the world to say, let's make sure the converter technology we're using in Marinus Link is designed in a way that works in this changing power system and actually helps to stabilise and strengthen the power system. So we're certainly looking at things like grid forming capability as part of the converter technology being developed for Marinus Link. So Basslink uses a slightly different form of converter technology. It was the best technology of its day, and at the time, we've had 15 years elapsed since then, and now we're working with converter manufacturers around the world who are basically building interconnectors, HVDC interconnectors between a whole lot of power systems that are transforming to have more wind and solar. I guess the other key thing that makes Marinus Link a key part of our future grid and a real complement to wind resources is that it helps unlock the deep storage resource that Tasmania's already got and has capacity to further develop. So in Tassie, we're already 100% renewable, and that's largely based on our hydro generation fleet. And in a world where we've got more wind and more solar coming online, we can use that wind and solar first and keep the hydro generation in storage. So it's essentially a ready-built battery that we can use to complement that renewable resource, that new renewable resource. Then we've got some of Australia's lowest cost, most cost-effective pumped hydro capacity, where we can repurpose some of our existing hydro schemes by building higher reservoirs cost-effectively to develop pumped hydro resources. And as our analysis shows, and as analysis that AEMO has undertaken shows, we're going to need a lot of storage. And some of that storage will come from batteries, small scale, medium scale, grid scale batteries. And all our modelling is showing that there'll be a significant investment in batteries right across the NEM. However, the modelling also shows that when we need deep storage, long periods of storage, the most cost-effective way to achieve that is through things like hydro and pumped hydro. And so when we have periods of time where we have weather systems affecting Australia, that's affecting our solar output, affecting our wind output for extended periods, we'll need access to that deep storage, and Marinus Link is unlocking that really cost-effectively. So we've undertaken a regulatory investment test, a RIT-T, and that analysis basically says that the costs of building Marinus Link are less than the savings that are unlocked by Marinus Link. So there's a net benefit to the energy market for progressing the project. And the analysis shows that it makes sense to build Marinus Link in 2 stages of 750 megawatts each. And that 750 megawatts is linked to basically how much energy the power system can lose in one hit. So the credible contingency that the market and power system can withstand. So we've got 2 stages, each of 750 megawatts. And we've tested the different capacities and different timeframes and different future scenarios. And Marinus has net benefits under all scenarios modelled and under all the sensitivities that have been applied to those scenarios. So it's got a very strong economic case. We know when we talk to customers, they're like, well, that's nice, but what does it do to my power bills? So we also undertook modelling to understand how Marinus Link affects the wholesale energy market and prices for customers. And the modelling that FTI Consulting did for us showed that, again, Marinus provides benefits compared to a world without Marinus. And effectively, there are savings in every NEM region in the order of $3 to $5 a megawatt hour. And of course, some regions use more energy. So there's benefits in Tasmania, there's benefits in South Australia, but the larger benefits are in the higher energy using states like New South Wales and Victoria and Queensland. So those wholesale pricing benefits are essentially achieved because Marinus Link is putting a lower cost dispatchable energy capacity into the market to provide that deep storage. And it's displacing gas-fired generation that would otherwise be required and provide that service at a higher cost. And it's also unlocking that wind generation in particular from Tasmania that is also lower cost. In addition to the benefits to the energy market and energy customers, there are also benefits to regional economies. So there's benefits in Victoria in the order of 1.5 billion from the direct investment in the assets and the stimulus from the work in the region, and similarly 1.4 billion in Tasmania. In Victoria, we're coming into the Latrobe Valley, a region in transition, and so we see we're a part of the transition for the workforce in that region. At peak construction in both regions, there'll be in the order of 1,400 jobs from the project, so it's a significant contributor. The other thing is that this is part of a cleaner energy future. And our modelling shows that there's in the order of 140 million tonnes of carbon dioxide cumulatively reduced by having Marinus Link in service by 2050. And we used to say, oh, well, that's the equivalent of taking about 1 million cars off the road. But looking at all the projections of cars, we've now qualified that to say petrol diesel cars, because the projections we and others are making is that increasingly our cars will be fueled by clean sources, including wind power. And in fact, I've just ordered my first fully electric vehicle, which I'm looking forward to powering with completely clean energy. So what are we building? We're proposing converters at each end of the HVDC link. This shows a diagram illustrating what they could look like. So one converter for each 750 megawatt capacity. Someone described these as looking a bit like Bunnings warehouse, but I can assure you the kit inside is a bit different. My husband would have less fun, I think, with the kit inside these sheds, but it's, you know, a whole lot of really modern technology, power system electronics that can help to create waveforms and DC, basically using power electronics. And as I said, in a way that also is supporting a more stable power system in a world that we've got more inverter-based connections. We're looking at building, having subsea cables, so 2 sets of cables across Bass Strait, each with 2 power cables and an optic fibre cable, and they'll be laid some distance apart for sort of security reasons, and that will be buried under the seabed, and it will be coming from northwest Tasmania, just outside Burnie, almost directly north across Bass Strait into the Waratah Bay area in Victoria. And then when we hit land at Waratah Bay, the proposal is to have in the order of 90 kilometres of land cable in an easement in the order of 20 metres. And each cable will be buried in conduits along that route. At the northern end of the route, we will be traversing an area that is where the Delburn wind farm is proposed, and we're working closely with them. And we propose to connect into the Hazelwood area and into the strong 500 kV network in that region. And as part of all our planning, we've been working closely with AEMO as the Victorian transmission planner about connection arrangements and power system planning arrangements. So we're well underway. There's a whole lot of stakeholder community engagement that's underway in Victoria and Tasmania, and with stakeholders in Bass Strait. We are undertaking a whole lot of technical and power system design and specifications to inform our plans and our procurement processes. We've commenced field investigations and sea investigations, including in the marine environment, ecology surveys, cultural heritage and geotech surveys. And we've done 2 marine surveys to date in detail across that route to establish we do have a viable marine route. And we've just commissioned another survey that is going to take the geotechnical sampling along the route to help with finessing the route, but also the detailed cable design. There's obviously a whole lot of commercial activities that we also need to progress. And a key one is kicking off a revenue setting process. So we've passed a RIT T, we're progressing the project as a regulated link, and we're starting to engage with the Australian Energy Regulator and with a whole lot of consumer as we start that revenue setting process. And we've started element planning and execution, including for the HVDC cables and for the converter stations. And we've recently pre-qualified suppliers for those processes. So our working timeline, we're in a phase we call the development, so the design and approvals phase. And that's the phase that we basically get all our environment and planning approvals, get our regulatory approvals to establish our income stream, get our contracts in place. So basically establish we can build the project and that it will provide a return to owners. Our present assessment is that we will complete that those processes and achieve final investment decision by around the end of 2024. And then it takes in the order of 4 years to have the equipment manufactured, installed and commissioned, with the first stage to be in service by 28, 29. And we anticipate the second stage a couple of years after. So basically we'll be rolling from one stage into the next. And then the asset can be in service for a minimum of about 40 years once from commissioning. So it's a really exciting project. It's a key part of Australia's future grid. It's got an important role to share our wind resources, solar resources, and hydro and pumped hydro potential. And ultimately what it's doing is helping Australia to have reliable and secure energy supplies into the future. It's helping to do that in a way that customer prices remain affordable. It's helping to do that in a way that's supporting regional economies, including the Latrobe Valley as it transitions from its coal-based economies. And something I feel really passionate about is it's part of enabling a cleaner planet for our kids and the generations to come. So it's a really exciting project to be part of. And if you'd like to know more, we've got a website and we're on the various social channels. So please get in touch. There's an email there if you have a particular question that you'd like to follow up in detail. And other than that, I'll hand over for questions more generally. Thank you.
Thank you, Beth. If anyone has a question, please email. We've just been mindful of time. We'll transition to Michael Lee, who has a very interesting topic as a question, which is wind farms and sustainable energy, insights into making better investment decisions in the Australian market. Michael currently leads the business development for COVID Conductor, as well as advisory services for ground line engineering. Thank you, Michael.
Wrong presentation. Mine's the orange one. Yep, that one. While they're putting it up on the screen, thanks for that introduction. I certainly hope to share with you some of my experience today. Even though at face value, you may think that my headline is little more than controversial. Well, it probably is, but let me rest assured I don't wish to be lynched by today's audience because I firmly believe that renewable energy wind, solar, pumped hydro, all has a place in the network. And it's a bit like an olive tree. Best time to plant it was 30 years ago. Next best time is today. There's things happening on my screen here. But, what I will share with you today, though, does impact us all. It impacts the real world viability of wind energy, and it represents an uncomfortable elephant in the room. Oh, okay, we're back on here. So, uncomfortable elephant in the room. What I'll share with you today impacts us all. I'm talking about our industry, an industry that stubbornly remains passive and even complicit in the commissioning of infrastructure using 1950s technology for the poles and wires, and that today and into the future will continue to deny our communities and renewable energy investors the social, environmental and financial benefits of wind energy generation. Beyond this, I suppose over the next 15 minutes or so, I'm asking everyone here to think about the role of energy loss, to question who is accountable for minimising and preventing losses of sustainably produced energy, and how the cost of these losses is shared, and how in the real world here in Australia, this impacts the sustainability of wind generation. Okay. Where are we? Going that way. So what do our wind farm owners and the general public want from our transmission lines? Well, I think that's pretty simple and pretty clear. They want to be able to put a lot of clean energy into the network safely and at a good price. We know what we don't want. We don't want unpredictable grid connections, associated delays to commissioning, increased congestion, all the things that we've heard about recently. We don't want long-term energy market designs that are complicated, anti-competitive agendas, or a political landscape that delivers with one hand and takes away with the other. Let's just say that a lot of that is above my pay grade, and my focus from here is more technical. For many, it's grey, but I'm here to tell you that it is actually black and white. And I'm going to talk a little bit about what's traditionally used and what's the readily available alternatives are. So what we have is, I jumped around. Sorry, it was a lot easier. Okay. Here we go. What we have is a bit of a mess, really. Perhaps it's a little bit harsh to say that it's this bad as this picture. I don't think there's a lot of paperwork to make a connection there, but I wouldn't want to maintain that network. Anyway, customers want their lights to work when they flick the switch. They're less concerned about how it gets to them unless they worry about what their backyard looks like. But we do have systems that have progressively developed over the years, and it could be worse. Customers do flick a switch and the power goes on, but the cost and environmental credentials are out of step with what modern society wants. Not many people think about how we move power from point A to point B from an engineering perspective, or what huge influence the towers and lines that were built in the 50s and 60s have on the sustainability of the network today. It's often easy and maybe even convenient to think solely about new generation, 3,000% extra something, that's added to the network as the primary lever for the sustainability we seek. The transmission network has not kept pace, and where there is a massive effort going into sustainable energy, it lacks the focus of where we're losing the energy. It's like an overflowing cup. We keep putting things in, but we haven't changed the size of the cup. Putting an engineering hard hat on, the technology has come a long way since the bulk of our transmission network was installed. The Snowy Hydro Mountain system was built by my grandfather's generation. The people who built the transmission line to Portland Aluminium Smelter did so before I graduated with my engineering degree, and I've been working for over 3 decades. Sure, today a 1950s car, well maintained and cared for, is a bit of fun. Usually it's a fun day out. It's an old man with a hat on that slows down traffic. It's a bit of fun on the weekend. With a more modern car, your service interval's longer, more fuel efficient, you get there safer, you've got a lot more reliability. It's basically the same with transmission lines. The problem we have is that a lot of our network is old, and when it comes to upgrade, seldom is the latest technology used. The low capital cost approach to investment that permeates the way many in our industry think and operate means that when it comes to replace that old 1950s car, we replace it with a new 1950s car, not a 2021 model. This is to the detriment of our grandchildren and everybody with an intimate interest in growing wind energy. Segueing to those of us here today because of the role we play in setting up wind farms, connecting them, making investment decisions easier, and juggling the hurdles to overcome. The issue is that the ecosystem has not kept up with the need to plan for new generation. It's designed to plan for new load. Governments control this, but haven't made the necessary changes through their existing bodies. Instead of fixing the issues through existing bodies, we now have new bodies for added complexity. To ensure the correct investment is made for transmission lines or undergrounding or non-network solutions, there are many, many more bureaucrats involved in this process now. And think how the regulatory framework and the consideration to connect with renewables has changed in the last 20 years, from 2000 to 2020, or from late 1998 when the NEM began. During this time, just 3,000 kilometres of transmission conductor was added in Victoria and New South Wales. More than this was added in 5 years from 1980 or in an 18-month period in 1967-68. Getting back to my happy place of engineering 101, let's look at what we want to do. We want to add solar and wind and move power from point A to B. There's a physical limit to the amount of energy a conductor can carry, and the physical reaction impacts the design. It's no secret. People seem to know this. For how long have we been predicting network issues with rooftop solar? As long as we've had rooftop solar. How long have we been talking about loads here, customers here, we've got an issue? Decades. Anyway, physically what happens is the conductors heat up and the balance of the conductivity and the metallurgical properties determine the size and strength of the towers and the spacing. The properties and temperatures of the conductor determine how tall the towers are, how strong they are, how much steel, foundations are all used. How far off the ground is managed by standards and safety issues. Throw into the mix cooling effects of wind, snow loads, birds, things like that. It's a complicated engineering challenge. However, we know what the constraints are and the nuances currently are, and that the designs are complicated, but good engineers can manage all that. So let's take, for example, one of these nuances, localized weather conditions. Efficient local area monitoring or the deployment of dynamic line rating systems is commonplace overseas. It is now global best practice with data collection and management undertaken in open, controlled manner. The UK regulator Ofgem is a good example of this and how it's done using high functioning and independent structure. Here in Victoria, we rely solely on the blunt instrument of broad weather analysis to assist our grid management. Back to the core of the technology of poles and wires that were built in the 50s and 60s. It's fairly conservative to what we can do today. We can make the conductors stronger, space the towers further apart, deliver better outcomes in doing this. From a pure engineering perspective, the fundamental concepts we're tackling is more power going in, the conductors get hotter. The hotter they get, the less efficient they are. And who pays for the losses of an old backbone? There is a maximum temperature that the lines can run at, and when the lines run hot, the losses are much, much greater. Good design has excess capacity to allow for maintenance, shutdowns, cope with emergencies. But the longer the transmission lines are, the losses need to be accounted for more thoroughly. Similarly, transmission structures integrated across borders offer greater resilience and long-term stability. The threat of an island network like the recent Texas winter experience is all too easy without interconnections and cross-border collaboration, not this state, that state, all on their own. So who really is accountable for providing the leadership to mandate this collaboration? Look, this isn't about more investment. We can do a lot with what we've got. There are lots of different solutions freely available out there, depending on what you want to do. Throw into this mix how we introduce or integrate well-placed battery storage or pumped hydro, to manage the intermittent cycles. As I said, these are all engineering challenges that can be defined and solved, but perhaps there are some forces beyond engineering that do us no favours. Let's have a look at the res zones. Some typical examples like this one in Portland with a temporary guide structure. It's a different type of tower structure next to the suspension tower, or these typical shots from Broken Hill and Kerrang. You can decide which one's which. We're not going to underground these transmission lines here. This is an ideal location for overhead line transmission. This is also fertile ground for a government to have a modern energy policy. A smart government would surely fund a network here. That's a no-brainer. More interconnections, more DC or HV transmission, and then let others who are smarter, more agile, and not encumbered with ignorant ideologies devise what generation assets they want to invest for a return. Money spent on transmission backbone is nation-building infrastructure, and surely is more sensible than propping up gas-fired generation or outdated refineries. But I'm preaching to a room of the converted here. This is not something you don't know, but let's illustrate some of the grey areas many of you may not know with this system. Let's choose a 300-kilometre transmission line. There's lots of examples. Eyre Peninsula, Mildura to Broken Hill, Kerrang Link, Queensland Interconnector, Copper String, Sun Cable. There's a lot out there. Energy Connect, bits of that. I'm presenting a generic 300-kilometre transmission line. I'll give you a moment to ponder how many tonnes of aluminium, steel and foundations are actually required to connect the wind farm that's 300 kilometres away that you want to commercially connect to load use. Have a think how much roughly that costs. Have a think roughly what the line losses are worth per year over 30, 40, 50 years. Snowy Mountain scheme started 50s and 60s, so maybe I should be saying over a design life of 70, 80, 90 years. How many years do we think this is going to last for? The case study numbers are just for the raw materials. And my point today, I'm just going to look at the aluminium conductor. You can come talk to my colleagues about foundations and steel. But there's a lot of aluminium. And keep in mind this $100 million for a reasonable sized transmission line, the capital cost of the conductor. Let's have a look at the conductor up in the air and the ongoing costs, losses, if they can be reduced from 5 to 4 or 3%. The operating temperature can be reduced by a few degrees by moving from a 1950s to a 1980s or a 2000s design. The procurement people in the room should be asking themselves, where does this aluminium come from? Well, rest assured, the procurement people are in the room, but the suppliers are overseas. And that is a topic for another talk. But if we just consider the aluminium conductor, a 1950s type conductor has a steel core and an aluminium conducting layer. It's an aluminium conductor, steel reinforced. We've at least updated the imperial dimensions to metric in the 1970s. Since the early 80s, all aluminium alloy conductor 1120 has been shown to have a much lower resistance. Further improvements in the conductivity can be made by compacting the wires. You have to go overseas to see that in the air. There's none of that in Australia. The line losses are quite significantly different. And it is interesting to see which new long transmission lines or old ones reconducted are going to install AAA C1120. Comparing the two over a 300 kilometre long line and a typical line, the difference in line losses World Bank model is approximately $1 million a year. If you take a less conservative one, 3 or 4 times that. Who is disadvantaged by these losses? The wind farm, the consumer. It's also worth pondering who cares and who benefits from not addressing or reducing the line losses. Then we compound the physical resistance differences between an old conductor and a new alloy with marginal loss factors, which basically vary by how far it is from the generation site to the load demand. And the stringy old power lines in between. Solar farms in the outback are a bit more disadvantaged to wind farms on the coast near smelters, but the loss factors vary year to year, but the physical infrastructure hasn't really changed. So topic for the panels are how to share equitably the losses and not just on new connections. So I'm going to go a bit longer than that. This is all part of the complex metallurgy and engineering that is considered just with the wires. So it seems reasonable to me and for wind farms that I work with to say, what works well overseas? Some gentleman from Jacobs asked that. I direct you to Brazil and Africa. Brazil is a good example and has been expanding their transmission network dramatically over the last 20 years. They use an auction process to manage the total costs over the life of the line. Thousands of kilometres of AAAC conductor have been installed instead of the steel reinforced in the last decade. They even utilise the experience in the Australian and New Zealand standards. The African experience, where there are a lot of projects funded by the World Bank, also take a long-term view of the financial cost, the total cost of ownership. They look at the costs of installations of novel tower structures that use less foundations. These are being rolled out throughout Brazil, South Africa, and the rest of Africa. Compact aluminium designs have been around for decades, not used in Australia. They are more efficient, they have lower resistivity and better wind loading. You could look at the use of DC lines with lower line losses, which are also being utilised. If you have the luxury of starting with a greenfield site, you would look at these latest technologies. In a brownfield site, there are some decisions to be made for what's appropriate to employ. But I'm here to promote the discussion, and I'm interested to hear the justification for, with a clear conscience, why people are installing older high-loss designs. In closing, in order to avoid whistling into the wind, our transmission network needs leadership, coordination, independence, and importantly, a long-term view. Our ageing backbone transmission network needs some reinforcement with best practice engineering, supplemented with new infrastructure. The network needs interconnections, coordination, independent review, and a focus on line losses, and a much, much greater sense of urgency. This will undeniably make connecting new renewable energy sensible and sustainable. Socially, it's desired. Technically, it is doable. And we have most of the people right in the room today to kick off the discussion and plant that new olive tree. Thanks.
Thank you, Michael, for the very thought-provoking session. I think it was a good point to go from here to the break. Michael is here, and I think, I highly encourage to have discussions. So we'll have about almost 30 minutes. At 4:05, we will continue with the next panel. Please go for coffee, go to the exhibition, or stretch your arms and legs for a bit so you can get back fresh for the last session. Thank you, everyone. It's great to see that we still have people. And for me, this is one of the more interesting sessions because it's related to what I do work. So without taking too much time, our session now, this is the last panel session, and it will be about the pros and cons of spot market and PPA, a power supplies perspective, which is an important part of the market because this is in a way what the revenue is created in the market. We will have Elaine Consolo to moderate the panel. She's a partner in the energy and projects team. She specializes in renewable and clean energy project development, energy regulatory matters, and energy contracting, including hedging and offtake arrangements, connection arrangements, and retail arrangements. She also advises on significant energy and resources M&A transactions and unincorporated and incorporated joint venture and shareholder arrangements. She's a member of the Technical Advisory Committee to the Business Renewable Centre Australia. Please welcome Sarah.
Thank you for the introduction, and thanks for coming this afternoon. I think we're a little bit down on numbers, so I think drinks are calling, so extra appreciation for everyone who's made the effort this afternoon to see our panel. I just want to begin by acknowledging the traditional owners of the land on which we meet today. I would also like to pay my respects to elders past, present, and emerging. So today we're talking about the pros and cons of PPAs. PPAs are generally essential for the development of any project. Without a PPA, a project is exposed to the volatility of the spot market, whereas a PPA gives the opportunity for long-term fixed price certainty. Traditionally, the PPA market was characterised by purchasing of energy by retailers, but now the market has evolved. We're seeing corporate buyers entering into PPAs as a means of meeting their sustainability objectives. And the change of buyer mix is really evolving the PPA market. We're seeing new structures and new trends, and this is creating different models from a supplier perspective. So today we have a panel, a very expert panel to talk about PPAs from the supplier perspective. Before we get into the topic for discussion, I'll just turn to each panel member to introduce themselves. So just starting with Anthony.
Thanks, Eileen. So my name's Anthony Yates. I'm the EGM Business Development for RACH Australia. I look after both our project development business and our project delivery business, so nursing projects through construction and into operations. RACH owns a bunch of power stations located both on the East Coast and the West Coast, a mix of gas, solar and wind generation. In terms of the projects we've brought through to operations in recent years, it includes 3 large wind farms and 1 utility scale solar. And in terms of our developments, we're currently looking at wind farm projects, solar projects, wind or solar integrated with battery projects or standalone battery projects. So we're currently investigating the feasibility of a whole range of different options and opportunities. In talking today, I'll be talking from the perspective, I guess, of a project owner and of a generator. So someone looking to source an offtake contract with an offtaker.
Hi everyone, my name's Steph Easton. I work for Iberdrola Australia, and there I head up the 24/7 team. So our team's responsible for the spot market participation of our assets, as well as providing 24/7 oversight of those assets as well. Iberdrola Australia is really an energy service provider. So coming from what was really a wind farm, more infrastructure type fund, asset manager, these days the company's portfolio has expanded with gas turbines, battery storage systems, and predominantly is now able to provide a retail service to large C&I customers to provide a clean, firm supply of electricity. So my perspective on this really is I get to then sit at the other end of that, which is how do you manage that risk within the spot market and make an optimized decision that meets the needs of customers today.
Okay, thanks, Steph. My name is Byron Sargenson. I'm the Chief Operating Officer at Flow Power. And I guess for those who don't know who Flow Power is, we are a C&I retailer that's quite focused on renewables specifically. I guess we feel that the retailers who have a kind of pro-renewables mindset have a great role to play in connecting projects with energy users and also helping energy users with their consumption patterns to help use energy at the right times of day to better align with projects, to help kind of foster the renewables transition. We work, I guess, with a lot of different projects, from project developers to C&I customers or corporates who are looking to be kind of cornerstone investors in projects. I think to date we've got roughly 10 PPAs out there with utility scale projects and probably dozens with corporates. So yeah, I think from this perspective, this discussion, really trying to talk to what structures we can seeing in the market at the moment, what trends we see from the project's perspective, as well as consumer energy end users, and kind of how we kind of put that together to solve problems.
Thanks. Hi everyone, my name's Alice Forsyth and I'm here from Pacific Hydro. So Pac Hydro Australia has a long history of renewable development and more recently has got into retailing through Tango Energy. My role is wholesale origination. So I sit between project development and assets and our retail business or wholesale customers. So yes, the perspective I'm bringing here is understanding the project development cycle risks, our company's risk appetite, those sorts of things, and trying to balance that with the needs of users and the customers that are looking for those PPAs and offtakes.
Great, thank you. So our topic today is pros and cons of spot market and PPAs. The question I'd like to start off with is, what are the disadvantages of a PPA and an advantage of of merchant spot marketing? The advantages of PPAs are quite well known. So we'd like to sort of flip that on the head and explore what are the disadvantages of PPA and the advantages of merchant contracting. So I might start with you, Anthony.
Sure, thanks, Eileen. Look, as Eileen said, the pros to a PPA are pretty obvious. And I think in conference sessions like this, there's been numerous sessions talking about the pros of PPAs. It is worth remembering that there are a number of downsides to a PPA. Obviously, as a long-term contract, what both parties are doing is locking in risk positions and locking in pricing that they then need to manage over a long period of time. As we've spoken about, or as many of the other speakers have spoken about through the course of today, Australia's energy market is constantly in a state of change, transition. So locking in long-term risk positions and pricing in a market that's constantly evolving is certainly very challenging. And you can find yourself under significant pressure either through various step changes that occur or just through various periods, depending on what changes may have occurred or what events may have transpired in the market. I think the other thing that's interesting and is a downside of a PPA is that in the energy market, there are inherently, I guess, conflicts of interest between the objectives of the generator and the objectives of the off-taker. And through a contract, you need to lock in a regime to try and deal with some of those conflicts of interest. As the market continues to evolve, those regimes become ineffective or inefficient and probably aren't the optimum outcome for either party. An example of that I can cite is ancillary service costs in the market. So typically, there's a strong correlation between periods of high ancillary services costs aligning with periods of high spot pricing. As a generator who's locked in a fixed price under a PPA, generating through those periods of high ancillary services costs is not ideal. For the off-taker, they obviously want you generating through those periods of high market pricing because they want to benefit from the upsides there. So yeah, you find yourself contracting into these arrangements to try and manage all of those inherent conflicts of interest. And as the frequency or the nature of those events change, those regimes become less effective. So yeah, certainly there's downsides from our perspective as well as upsides to a PPA.
Thank you.
Strategic point at an off-taker.
I'll pass to Steph.
I think when you think about PPAs versus spot market, it's always worth remembering that every megawatt hour in the market design that we have in the NEM still needs to be traded through the spot market. And the spot market still underpins, your future view of the spot market will still underpin the viability of a product, wind farm, solar farm, and the expectation of where that market's going to move in the future. So it's a variable resource that we're talking about with contracting wind or solar, and we have variable demand for electricity. So there is a lot of uncertainty, and ultimately when you're contracting, you're looking to delegate that risk between parties. So it does become a horses for courses in terms of, whether or not PPAs actually are advantageous to all parties over time. And I think Anthony's point about, that you have to make some commercial decisions that you're ultimately held to long term really can be the downside of PPAs, is that you're taking both parties, or both parties could be multiple parties, are taking a view of the future and really locking it in upfront. And so I think that with PPAs, it can both impact financially one party, death by 1,000 cuts, but it can also make the future investment in renewable energy unsustainable, because those assets still need to trade through the spot market, and you really lock in the operational regime often when you make those commercial decisions up front of those assets, or at least that's been the case to date. And it can be the case that flexibility of renewable energy is actually taken away because there's a commercial agreement in place about how it should be operated. And so maybe that degrades what the spot market looks like and kind of makes future investments less sustainable as a bit of a unintended consequence.
Okay, yeah, I think some really good points there. And not to repeat anything, I guess some of the things that we see in terms of the challenges of PPAs are really, timing is a big one. I guess timing is the perennial challenge of a lot of developers, trying to get everything to the finish line at the right time for project finance, grid approvals. When you're adding another PPA on top of that, particularly with corporates or other groups that are not so flexible in their timing or less understanding of the challenges of grid and things like that, as developers know it, it's just another risk that can go wrong with projects if you pursue that strategy. Also, what we're seeing as well is that for projects or project finance, when they're looking at timelines and delays, often the idea of going into LDs is really avoided at all costs from a project finance perspective. So even when projects can be a bit late and effectively pay that, it might in itself make the project quite difficult to get up.
Yeah. And adding to, I guess, all of those points of view, a specific example of where having a PPA can be disadvantageous is when you're developing your model to build a project. You have revenue assumptions, you have a myriad of assumptions that goes into those models. If you, for example, have an assumption in there that a large generator is going to retire in 15 years, then that has certain impact on the market. If you lock in a PPA for 10 years and then that asset retirement happens after 7 years during that PPA time, it's kind of a whole of project issue. So perhaps that 10-year PPA is set to, ensure you can repay debt and make your required returns for those 10 years. But if you're looking at the whole of project, it may mean that the tail has changed because certain assumptions you've got in there have changed. Now, we all know that everything is changing all the time, but it's just some of those really big things. It can be disadvantageous to have a PPA locked in there. And I think I would also echo the conversation, the advantage of having merchant exposure from a spot perspective. So we're used to thermals. For example, if you're modeling gas, you may say 75% will be contracted once you're up to spot. And, the last unit is a swing depending on gas price and market conditions and those sorts of things. And there's an argument that there's, a certain proportion is based on short run marginal cost. And then there's a last bit that's trying to manage the long run marginal cost of that asset's return, financial returns. So I think we're evolving as a market, and we're kind of getting more into those sorts of requirements for renewables to participate in the spot market like that, because it does impact the credibility and the future projects that are being developed.
Thank you. And I'll just add to that. I suppose what I'm starting to see is a bit of a combination where your projects are quite conscious to leave a merchant buffer and have the PPA to achieve financing, but the merchant revenue to provide a return to equity, but also providing, you know, as a buffer as well against, for example, minimum generation, you know, liquidated damages that they can tap into that merchant buffer. I thought I'd just like to turn now to some current trends in PPA contracting. Just, you know, interested to see or to hear about how the revenue models and contract structuring are sort of evolving, what options there are, you know, from a supplier perspective. I might start with you, Brian, if that's okay.
Sure. Yeah, no worries at all. Yeah, I think it's fair to say that the trends around PPAs are always changing, always evolving. I think, you know, you've gone from seeing more CFD style PPA offtakes in the market to customers looking at sleeved arrangements, and firming now is becoming a more important consideration with market volatility and more understanding of how offtakes can play out in the market. Another thing that we see changing is the kind of question around additionality versus, is my project going to be operating when I need it to? That's another one. You know, buyers are interested in creating additional projects, but equally when they've got a target for 2020 or 2025 and there's uncertainty around where the project be ready, you see a tendency moving back towards projects that are already operating to fulfill some of those renewables targets. But yeah, I think from a project perspective, I guess, you know, projects are becoming maybe, well, they always have been, but become even more sensitive to risks of delays and supply chain and all those things that play out when it comes to setting, when it comes to COD dates and that kind of thing. And I also see kind of negative pricing becoming more in the mix when it comes to offtakes, and how do you deal with negative pricing, things that weren't really a concern a few years ago when it came to PPA arrangements. I guess maybe I'll just touch on quickly some of the things that I've seen kind of work out there with deals that I feel like has been good structures. I think, Aileen, similar to what you said, just that idea of the concept of projects having a cornerstone PPA, might be at a very low price, but basically enough to keep the lenders happy for roughly 50% of the project, and then kind of building from there, either through merchant or adding kind of smaller but more high value PPAs once there's certainty. Seems to be a good mix we've seen. Equally, I think projects that are doing more fixed volume seems to be resonating well with energy users as well. Basically, the project is in a good position to make a call on a fixed, rather than just a fixed proportion of offtake, but a fixed generation amount, which helps corporates meet their requirements because they know they need roughly a certain amount of LGC or whatever it is per year. I think from a project's perspective, it's quite easy to kind of lock that in because you've got a merchant buffer, but from a corporate perspective, it's quite highly valued, we see. So I think that's kind of a good strategy at the moment.
Yeah, that's really interesting. Stephanie, were you able to add to that? Be interested in your perspective.
Yeah, I think so. It's probably worth being transparent that as a company, we've really moved to diversify our routes to market for what we do with our clean energy. So these days, it is a lot more retail focused, and that means that in-house we have to manage the risk that comes with that, of our customers need to consume power when they want to consume power. But that doesn't mean that we're still not interested in being PPA off-takers, having proportions of our assets that are sold with PPAs where we're the seller. And I think being in the market and having a look at the products available, and also how we can package our own clean energy, you can see that there is a pretty good feedback loop if you look back over the last 5 years, both from a climate and emissions reduction conversation that's happening throughout the nation, and then also, I guess, just within our electricity industry, the feedback loop from the spot market. So there's still assets that are operating without a price floor type mechanism or a turn down mechanism in their contract. And that's, you know, you can kind of see that the spot market starts shifting the value distribution of those contracts, and all of a sudden any new contract has that consideration. I think FCAS prices just kind of becoming a whole new market from, you know, rounding error on balance sheets to all of a sudden really significant cost and risk that has to be managed. And I think then if you jump to the social side is really corporate PPAs and the willingness to do voluntary surrender to meet their own emissions reduction targets. A deal that we're really proud of recently was really a combination of a couple of those. So in South Australia, we did a deal with BHP that was pretty much a hybrid between a PPA and a flat swap. And it's linked to the Port Augusta Renewable Energy Precinct, which will have its first megawatts out very soon. And so I think that was, for us, a really good example of engaging with customers, understanding and going through, as Byron said, that understanding of what is the risk for corporates who do take on PPAs and how can that be managed so that, it gets an outcome that I guess is sustainable long-term for both parties.
Thank you. And Alice, just picking up on the theme before with sort of PPAs, a foundation PPA being entered into to secure financing. From your perspective, do you think there's a sort of an opportunity for financiers' sort of perspectives on PPAs to evolve and support the growth of the market?
Thanks. We've found that financiers are still taking a reasonably conservative approach, unsurprisingly. They're very focused on contracted revenue and the quality of that revenue. So the structure of the contract, risk allocation, as well as, creditworthiness, whether it's a tested retailer or, the creditworthiness of the counterparty. And when there is something out of the box, when there is something kind of a bit different or a newer counterparty, we've found financiers are using very conservative assumptions. However, bank thinking has evolved. In the past, you sometimes needed, a 15-year offtake with one of the big three to secure a decent debt size. And there have been fully merchant projects that have received financing. However, the debt sizing is impacted by those structures. I do believe that there will be an evolution though, because as we go through this clean energy transition, I think everyone in the market will need to get a bit more comfortable with volatility and the timeframes around that, upside some quarters, some years, downside others. But I do believe that, that both sides will, and probably financiers will have to get a bit more comfortable with the volatility that is predicted as we go through this transition.
Thank you. And Brian, I'm interested to hear your perspectives on flow power. What sort of options for overcoming bankability issues or different strategies does flow power adopt?
Yeah, it's a great question. And I think, I agree with Al. You see banks are moving, but probably are slowly, quite slowly, but you do look forward and see a position where we feel like we probably need to be as a market in the future. I think that what's been helpful is there's the amount of competition around lending for new projects. There's a lot of money, particularly international, that's seeking a home for investing in renewables. I think that helps to kind of get the lenders to think a bit differently or more relaxed around what offtakes look like and how they're structured. We've definitely seen, I guess, deals where, and also to say, I guess there's been a bit of an evolution as well. Early on we had a lot of government contracts, and there's kind of very big players in the market. The Telstras of the world out signing deals, but there's a whole nother piece of the renewable energy transition, and that's kind of the smaller to medium sized customers or energy users and residential. And it's kind of they're the bit that's next, and it's going to require a bit more complicated thinking. I think where we've seen some success is around the aggregation of customers like that are within an offtake. So, for instance, where you've got multiple multiple off-takers within a deal. Their credit might not be the same level as a tier one corporate or government, but the bank's taking a view on the kind of collection of entities within that, kind of like a halo effect around the aggregation or diversity of people within the group. That's been one thing, but it is, I think there's still a long way to go, I guess, fair to say, around the structure and how down the line it can be sometimes.
So you mentioned sort of government role in contracting, and I suppose we're in the context where there are challenges with the evolution of bank thinking. I'm interested whether, what is the role of government? Is there a role of government to support offtake or projects, or in some other way underpin the development of new projects? Anthony, interested to hear your thoughts on that.
Sure. I mean, I can say, I suppose, that there have been times over the past decade or so when government's stepping in to help promote renewable energy via revenue contracts has really stimulated the industry. I think the ACT feed-in tariff processes that were run maybe 7 or 8 years ago are an excellent example of when government stepping in to help kickstart things really does work. I would say at the moment, though, that I don't think government stepping in and assisting with offtake contracts is really where I would look for government assistance to try and stimulate the industry. As someone who's developing projects and trying to get new projects into the market, the biggest challenges that we face are some of the regulatory hurdles that exist. And governments obviously have a very strong hand on guiding those regulatory influences. For a wind farm, for a new wind farm greenfield starting today, if you could get into construction within 5 years, I think that's a pretty optimistic time frame, and therefore your first generation within 7. Those kinds of timeframes are staggeringly long for companies looking to invest in new projects. We've heard numerous sessions today talking about the complexities of the grid connection processes. I think some sort of top-down effort to streamline those would certainly assist. And equally, I think the last session speaking passionately about the need for some sort of coordinated and future-thinking approach to network investment. They're really the areas that I'd be encouraging governments to get involved in. If they can make some of those processes easier, I have no doubt that we'll see projects flow into the market much more frequently than they are at the moment.
And Stephanie?
Yeah, I think Anthony's made some great points. I think where the wind and solar industry has come from is that the arguments at this forum 5 years ago would have been first justifying why we need to move on climate change, and then that hence justifies why you should subsidize megawatt hours of renewable energy into the grid. I think that the pulse of the conversation today is not that that's the case. I think everyone knows that those megawatts are competitive to build, but the challenges that are being faced, especially if you look towards a grid where you can supply all of customers' electricity needs with clean energy. And that's in a world where we're encouraging electrification because, what electricity can do for the decarbonisation challenge of the world. We've got a lot more technology and smart solutions integrated into how we work. We're already getting the challenges popping up. I think that on a regulatory point of view, there's some really important conversations happening about what are missing markets or services, or what is our grid missing and our market design missing into the future. And so I think that there is definitely a role for government, because some government initiatives have been phenomenal in terms of advancing renewable energy, and we definitely don't have 100% clean grid yet. Whether they should subsidize megawatt hours of competitive technology, I don't think that's probably the right place. I think where you have monopolized industries, that's a good place for government to provide guidance, setting clear emissions targets that markets can be built around and investment certainty can be based off. We do have really high quality offsets like LGCs and ACCUs on a global scale. They're high quality market mechanisms for thinking about offsetting. So we've got some really good bases domestically. And then I think also in the R&D space, where they have been successful with things like ARENA and what they're able to do for commercial solar. that is government funding into a government agency. So I think there's definitely a role for government, but probably the biggest leaps and bounds will be found in spaces like R&D. And from a policy perspective, I think that the brains in this room indicate that we have a strong industry who are thinking about how to innovate around the problems and challenges that we have, but everyone's probably looking for clear direction and making sure there's not too many speed bumps along the way, knowing that there's definitely going to always be some.
And I think the end of the RET is interesting. Up until now, off-takers of green energy or LGCs were contracting up to the expiry of the RET. I think the general expectation is that it will get replaced, but what I'm now seeing from a corporate buyer perspective is an increased appetite in contracting for green rights, whatever they may be, beyond the expiry of the RET. So when it comes to that time, when all these businesses are coming off their contracts, they're not competing at a very high price for this new green commodity that's going to be in high demand. And I think that sort of evolution is a little bit different from what everyone was expecting. But at the same time, I think the expectation is the RET will get replaced. We will have an opportunity to throw to questions from the audience, but before I do that, I would like to give the opportunity to each of the panel members to make a few closing remarks and pick up on any of the discussion points that we've spoken about to date. Alice, I'll start with you.
Sure. In closing, I guess from a developer's perspective of PPAs, it's at this stage about creativity. So it's about thinking ahead post 2025 restructures, all the different scenarios that may play out, and thinking more about the demand. So less just kind of supply side of a developer, but more whole of market. How can we supply the demand as it is and promote demand promote electrification, being physically sourced from renewables. So yeah, I guess I would just say it's a really exciting time and there's lots happening, but it's all about creativity, flexibility, and just getting out there and getting this clean energy transition continuing. Thanks.
Yeah, look, I think that's a really great point. I feel like we have been through a period of where there's been the same thinking that's kind of carried us to this point in time, mostly around, as we talked about, big corporate offtakes, tier one corporates, government contracts, things like that. And I think how we get to the next phase of the renewable energy transition is really about the creativity. How do we work with, how do PPAs and the relationship between the project and the energy buyers fill the gaps with project uncertainties, things like FCAS, things like negative pricing, things like the end of the RET. How do we kind of structure them together and I guess let the communication or understanding play a stronger role in how these deals come together. That's kind of what's needed as the next phase, and I'm very confident we'll solve it. As an industry, the wind, here we go, is a pun, but I think the wind is at our backs. It is carrying the industry forward. It's a great time for renewables. So I've got no doubt that that will solve these problems over the next few years.
I think maybe to come back to the spot market in my concluding remarks of, I probably was a bit pessimistic on PPAs in your first question, but didn't talk too much about what are the pros of the spot market. And I think as in wind industry, it's transitioning from, being able to supply clean energy into the grid and knowing that it would be to a quantum that didn't tip the needle too much, to more and more that's going to change. And I think for the growth that's required, that will 100% change over the coming years, is that the real-time operation of wind farms is going to be critical to what the next investment is, and it will heavily influence the spot market. And so I think, whilst investment is a massive challenge and planning is so big because obviously wind and solar are so capital intensive, I think it's also important as an industry that we engage more and more with what's happening at spot, both because it's really fun, but also because I think, wind assets, solar assets, renewable assets, they're going to have to actively in the future set those markets and understand those markets. And I think there's a lot of benefit that you bring back into your planning decisions by understanding the pulse of that market and how it is rapidly changing, to understand some of the upcoming challenges that as an industry we're facing.
Sure, thanks. And I suppose for my closing remarks, I'd probably just echo, I guess, what Alice said earlier. She was talking about the need for the industry to always focus on, or to continue to focus on, the demand element of things as much as the supply. There's a very old adage in any business that the customer is always right. And in the renewable energy industry, it's the people buying the energy that are our customer. We're seeing them increasingly want to buy renewable energy, which is great, but also they're looking for more reliable supply, firmer supply, time of day supply, and those sorts of things. So I would say for us as an industry, and particularly in the context of a discussion around the pros and cons of PPAs, being able to build some of those structures into our PPAs and into our energy supply such that we can satisfy customer needs, that's ultimately the way we're going to be able to continue to progress this transition with renewable energy. Thanks.
Right, it's really interesting perspectives. I really like creativity in PPAs. I think I might use that term from now on. We've got some time now to take questions from the audience. I think we've just got the one mic, but we can move around. So if anyone has any questions. Perhaps too late in the day. We've got one on the far right.
Hi, Ruth Guest from Evolution Energy Advisory. I'm curious, and it might be an obvious question to you guys, but it isn't obvious to me, how you manage a PPA if you've got a portfolio of, say, wind farms where there's a variable resource that isn't firm. So how do you manage a firm PPA?
As a seller or a buyer?
As a seller.
I think the benefits of selling a PPA is probably more at a business level. You want cash certainty, you want to be able to get that project off the ground. And so I think not fully contracting out an asset, one of the trends that from our point of view with our portfolio does start to come into play, because when it comes to decisions, your optimized portfolio, and it all of a sudden becomes very financial that you've got a sold position and a bought position that you kind of are trying to make up in the market. And so, once you've got a sold PPA, it really just changes when you're looking at your stack of short run marginal costs and I think that real-time optimization, PPAs are quite straightforward, that you've got a commercial deal and you want to optimize that commercial deal. But what that can mean for a portfolio of assets is that you have less flexibility probably if your PPA asset. The black and white financials want to usually maximize the generation from that asset. So you look for flexibility elsewhere in your portfolio. So I think that's the balance that you have, is that you're looking for a business benefit, but when it comes to the real time, the flexibility of the PPA probably, your portfolio flexibility probably reduces with your PPA contracted generation.
And I guess I can add by answering the question of how can you sell firm when your asset is non-firm effectively. And as a renewable generation business with a retail arm, that's what we need to do. So there's the build or buy for firming. So what you need is fast response for FCAS and for 5-minute variability. But then there's also kind of longer storage. And this is a wind focused thing. So I kind of haven't gone into storage where there are a myriad of wonderful things and interesting things happening in contracting there. But yeah, it's effectively you need to build or buy contracts around your wind farm to shape that and risk manage that to the customer profile. So yeah, short-term storage, long-term storage, or through the existing financial markets, or slightly tweaked versions of those existing financial markets of caps and swaps and the like.
There, another question? Oh, one down here. Thank you.
Michael Sherry from Green Power Monitor. This is probably to Stephanie. In your control center, if you're playing kind of in the merchant market, how has the change to 5-minute settlement with wind, which is typically a 10-minute game, kind of affected your operations?
I think I said earlier today that I'm loving it. But a lot of that's actually just almost a South Australia artifact. And this spring period has seen that many NEM demand records. And what's also happened is I think that we persistently started to see, at least in these shoulder seasons, negative prices in Queensland, Victoria, South Australia, and New South Wales tipped this Q3. And so 5-minute settlement kind of came at the perfect time to make sure that, you know, I think that there's a coordinated market now, a lot more around negative prices than we would have seen on settlement. And where I say that I was really happy, it's probably more a South Australian artifact where the bidding behavior, whether it's a human trader sitting there or an automated trading algorithm, still under 30-minute settlement, it's a really hard optimization decision to make. And you'd almost say that it looks a lot more like a game of chicken where you're trying to optimize both constraints, FCAS, maybe a portfolio effect. But, you know, we've got a really skewed market. And so $1,000 is quite a bit below typically the short run marginal cost of a renewable asset. So as soon as price would drop that far, you see large swings in the generation online. And so that type of dynamic in South Australia means that it's hard to operate it within. And also that I guess price signals probably weren't always the most efficient. I think it's meant that you kind of, even if you've got a negative price that you're kind of saying, this isn't necessarily fun for the business, bottom line, at least you can kind of reflect on it now and kind of say it's probably a good reflection of the short run marginal cost of meeting South Australia consumer demand. So I think it's a good indication of market efficiency. For wind, to be honest, I think the variability of wind, you know, for 5-minute market versus 30-minute market, that variability is something that we already thought about anyway. A lot of our focus has been on that unexpected high price volatility and how we can optimize battery decisions, how we can optimize fast start gas plant decisions. I think, I mean, talking about pumped hydro at a wind farm is one thing, talking about a gas turbine is another thing, but yeah, there's still not a lot of plant that actually can respond to a price spike in 5 minutes within the market. And so I think those high price spikes is the new thing that everyone's turning their mind to.
We do have time for another 1 or 2 questions.
Hi, Charlie Perry from Bivar. Just on the negative pricing, you talk about creativity in the contract, but I think it's probably for the sellers on the stage there. How are you managing that? Maybe the simple question is it on the plant side or is it in the contracts or a bit of both? Yeah, how are you managing the negative pricing risk?
Yeah, I can speak to a little, and maybe Alan also might have some ideas of what you've seen, but what we've seen in terms of trying to balance this, it's a great one because it's an interesting emerging thing, and how do you balance that within the buyer and the seller? What we've seen is things like a number of negative price hours through the year. So there's a certain cap on when it can operate negative, or certain thresholds in which it can operate negative, either pricing or number of hours time. And that way it gives a bit of balance to both. It gives the project knowledge that they can, you know, whatever it is, 300 hours of negative pricing, they know that they can at least operate at that floor for that period of time, but then beyond that becomes their risk of turning off effectively or managing it. So we've seen kind of balancing contracts, things like that, which try to strike that interval. That's the way we've seen it solved.
Yeah, and I'd say there was a discussion earlier around trends in PPAs, and certainly looking back 6 or 8 years where negative pricing wasn't a risk that was particularly prominent. And a lot of older PPAs are actually silent on the risk completely. These days, the risk is obviously very much addressed via the contracts. What we've seen is that they're typically being borne by the generator. not by the off-taker. So as an off-taker, sorry, as a generator, when I was saying before, under a PPA, you're forced to make some long-term decisions around risk and pricing. One of the assessments we need to make in entering into a PPA is how much do we think negative pricing is going to impact a particular project? How much do we need to effectively add as a buffer to our generation or to our estimates to make sure that we're compensating the project for the time that we anticipate to be turned off for negative price events? And it's one of those challenges that's certainly a downside to a PPA.
Yeah, just to add to that, so the most common contractual mechanism now is that during any negative price period, the spot price is deemed to be zero, so that the buyer's not exposed to the negative spot price. And then it's a decision for the project to generate if they want to, and they will only do that if it makes economic sense for them to do so. Where there is a tension, though, and I've seen in some of the latest PPAs, is that the corporates, they still want LGCs. So where there is a risk of negative pricing and the project's choosing to turn down, then they're not getting the LGCs, and typically that would be a relief from minimum quantity of LGC requirements. So I have seen some alternative positions where the negative price, for example, the floor is equal to, say, the estimated market price of LGCs, so that they're still getting the LGCs during those negative price periods.
I might add, it seems we've got a lot to say on this topic. I might muddy the water a bit with, I guess, a bit of a practical consideration. So I agree that the trend is definitely, buyers don't want to pay for electricity. So definitely the risk sits with the generator. As a project developer, that goes into your models. So you either change your volumes you expect, there's various ways of modeling that. And then also the capture, like how often are you actually going to generate into negative pricing and incur those costs. A contracting challenge is also working with the buyer or the demand on the realities of wind farms. They can turn down, each turbine can turn down a bit, then turn off. There's time, it takes time. If the asset completely goes off, there's, depending on your technology and your age and all those sorts of things, there are, different ways that they kind of come back on and different timing of that. So under your PPA, are you allowed to, you're meant to try and avoid the negative pricing, turn off. If the next 5 minutes is so you avoid the minus 1,000, the next 5 minutes is 15,000 positive, the customer is wanting that hedge. So it is also kind of, I guess, making sure that it's balanced, everyone working towards the same outcome. Doesn't want to be generating into negative if that hurts the customer. But yeah, it's a bit harder in practice than it is sometimes in the contracting. So it's just it's a good topic to talk about.
Yeah, it's a good point. There's been a lot more negotiation around turning off where you predict negative pricing events, I find, which reflects that practical reality. I think we've got time for another question. No. Oh, yeah. Sorry, I can't see you there.
I can have a first go at this one. Great question. I think that there's definitely a huge role to play for customers that can be flexible in how they use energy. And I think more and more with kind of new technologies and connected things, not only in homes, but businesses and large plants that are operating, I think we'll see more and more of it. It was a bit easier when it was more But the short answer is yeah. I think like from our perspective, more from the energy users perspective, energy users want to understand how they can, what they can do, what technologies are at their fingertips to basically better align their demand with times of generation. It might be from a kind of long-term perspective. So, you know, if they're looking at a solar PPA, for instance, the simple things of bring more generation during time of the day, that's kind of, there's kind of the low-hanging fruit there. But then there's an element which is much more, which solves the variable part. So getting kind of week ahead forecasts of what wind generation is going to be like in the next week, getting tools like that available so that they can basically plan plant decisions and things like that. Use of technologies to turn things on and off. Yeah, we're seeing a lot of it and doing good work in the space. Customers are definitely engaged on it. And I think it's that part will be a key part of the renewable energy transition, you know, helping to match demand needs of energy generation.
Might add to it as well. For our business, we're almost looking to do that in reverse. So much of looking at, you know, what projects fit within our portfolio assets is looking for a wind profile on aggregate that meets customer demands. And then similarly, when pricing retail customers, you might have a retail load that on face value looks really expensive to supply, but if it has a great correlation with our renewable output, we can be more competitive in that process because we know that we take on less spot market risk when we price that retail customer. So that's, you know, that's still customers being really not engaged. In saying that, there's still, you know, a lot of risk left over with all that intermittency. And so we do have a couple of retail agreements where we have large customers who are much more, I guess, involved with their energy consumption because it's such a large part of their cost structure. And, you know, mechanisms where there is financial benefit in turning off. And we see in those situations, we do have that kind of spot market relationship where I think similar to Byron is you're looking for opportunities to provide them with critical information about the market that they can make operational decisions on, and you can kind of share those financial benefits.
And perhaps the comment I'd make as well is it doesn't necessarily need to be that the demand is adjusting to suit the supply, or equally that the supply is adjusting to suit the demand. I think the situations where the demand and the supply come together to try and find a brokered compromise solution or partner on a project, that's really where you end up with the best outcomes. You know, and it may be that there are periods of the day or periods of the week or the month or the year where the generator will accept certain obligations to try and be much more firm. And then the demand can look to optimize its use during those periods, but then outside those periods, there's much more flexibility. And so it's kind of a compromise solution between demand moving or supply moving. It's a little bit of both.
Great. Well, I think that brings us at time. That was a very informative session from my perspective. I hope you agree. So please join me in thanking our panel today.
Hey, and now we are down to our last session. It's great to see so many people still here awake. You know, no, I can't see anyone sleeping. So, and I think the session was quite interesting. I think that's a testament to it. We'll now take, in a way, another step towards that question of trading. And the question now is automated trading. And I think, you know, when you talk about decision making, then trading is one of the harder ones because it has to factor a lot of elements into it. So our last keynote speaker is about maximizing profits and reducing risk with automated renewable energy trading solutions. Our speaker will be Harley Mackenzie. Dr. Harley Mackenzie is the owner and managing director of Hard Software. Hard Software has successfully provided innovative energy trading optimization software solutions for the Australian national electricity market and a range of consulting services to the energy industry for over 20 years. Before Harley founded Hard Software, he was the principal operations analyst at Yulon Energy, and represented the National Generation Forum on Information Technology during the design and implementation of the NEM. Harley has worked in the aviation industry, developing optimization software for crew and ground staff scheduling, and in the risk management industry. I'd like to invite Harley to give the last speak.
Thank you. We probably have a mixture of people who are very interested in revenues and risk in wind farms or waiting around for the cocktail party. So for those of the waiting around for the cocktail party, I hope this is interesting for you as well. My talk actually dovetails very nicely into the panel discussion that we just had, because a lot of the concepts that were discussed there I'll be covering as well. And I'll actually be providing some examples of the kinds of risks that we're talking about, especially with regard to optimizing automated trading solutions. Obviously, there's two parts to every making a profitable wind farm, and that is maximizing the revenue and managing the risks. And although we've talked about financial risks and things, there's a whole lot of other risks too that we need to actively manage. And there seems to be, and as the industry matures, we've gone away from the concept that you build a wind farm, you put one bid in a year, you let it run, and it prints money for you out the other end. That was seriously how people viewed wind farms when they were first being put in. Obviously, the reality is very different, and the regulatory and dispatch requirements for a wind farm have become a lot more complicated, and there's a lot more risks that you have to manage. There's a lot more systems you need to know to work out what is happening with your wind farm, and you need to actively manage your wind farm and not just expect it to be producing money. So the first question we have to do is, when we're running a wind farm, how do we understand what's happening at any point in time? That's the first step that we need to be able to go towards fully understanding what's happening and therefore adjusting our strategy to suit. So I have here a very simplistic diagram of what does a profitable wind farm have to do. First of all, it has a physical connotation. How many turbines are working? How many are out of service? Those sorts of things. Another aspect that is often neglected when running a wind farm is, are we actually compliant? And I'll come towards talking about compliance in a second. How do we manage the risks associated with running our wind farm? And those may be the financial risks, and those can also be the regulatory risks. And often it's the regulatory ones that don't get a lot of attention. And also, if I'm running a wind farm and something happens or something, some change in the market that we don't understand, where do we go to for help? I think we've all put questions into the AEMO help desk and realised that that is rather a long, convoluted process that may or may not result in an answer. So I need an answer now. What is happening with my farm? I'm losing money. What can we do about it? And that is a role that hard software prides itself in, being able to provide that support when you actually need it. So let's have a look at curtailment. We're all aware that wind farms get curtailed. The whole semi-dispatch design of the market is that you get a cap when you need to have your output reduced. Everybody knows about that. And too often the systems associated with semi-dispatch wind farms have focused just on receiving that market cap and turning the wind farm down. And that's a very important part. I'm not saying that, but it isn't the only thing you need to be taking into consideration. Obviously, you'll get dispatched off the dispatch price. If you bid your price in at, say, the negative LGC price, which is a common strategy, the price falls below that, you'll be dispatched. So that's a fairly easy one to see. You can see what's happening in the market. You can see what's happening in your generation. Obviously, constraints is a whole complex web of complexity. It's a whole web of interconnected things that AEMO needs to do to make sure that the electrical system runs nicely. Some of those constraints are easy to understand. Sometimes they're applied just to your wind farm or asset. Sometimes and more commonly, they apply to a group of assets and are due to the electrical limitations of the network. plus there are stability concerns and those sorts of things. So we'll talk a little bit more about that in the future, because there's a number of different types of constraints that you have to deal with. The other one is the system stability, and this is a whole new requirement on wind farms, that you're now part of the electrical system that has problems in certain areas. Obviously, these have been identified. I noticed in the diagrams we had earlier in the day, all those nice renewable energy zones seem to be around where everybody's having network problems. So it's obviously, they're good places to put stuff. Let's make sure that we have the network infrastructure to cope with that. So the problem is increasing, and one of the problems is curtailments, and this is curtailments due to a number of factors. This is an extract out of the AEMO 2021 quarterly report, and we can see that these figures are becoming quite extraordinary in terms of the number of curtailments. And recent history, with the recent last 3 months or so, we've seen since 5-minute settlement. I'm not saying it's a factor, but it's not the only factor going on here. We've seen a large amount of negative prices happening. This is not the right presentation. I did have a graph to show you. There was a vast increase in obviously in all of the regions that we're experiencing. We have South Australia has traditionally had most of the negative prices that we're seeing, but now we're seeing much more increase in Victorian negative prices, Queensland negative price, and starting to evolve value at this stage of negative prices in New South Wales. So when I said that things were getting more complex, what do we need to be considering in our management of wind farms? Element dispatch constraints is something that's new. They've come about due to the system stability requirements that in certain areas of our grid. And that's where we're, instead of being given a megawatt cap, we're being given a limit to the number of inverters or turbines, so the number of turbines in the wind farm industry, that you're allowed to have on at any particular time. So we're not just specifying meet the megawatt target, you're also being told how many turbines you can have running. And that's coming through the form of a special constraint that you have to intercept basically, and send that to your control system. And if you don't respond appropriately, you'll be given a zero cap from AEMO. Obviously, this is more prevalent in problem areas of the network, but we're seeing this increasingly implemented for a lot of the wind farms which we manage. So we're managing about 40 or 50 wind and solar farms, and increasing numbers of those are getting element dispatch. Also, we have voltage regulation instructions, which have traditionally been done with a telephone call or something. We're now implementing a system with AEMO to automate the voltage regulation response. And again, that one's not so much that you get turned off, but it's more about cooperating with the dispatch, the AEMO, to make sure that you're complying and providing your voltage support when it's needed. Availability submissions, which have always been there, but been very poorly done, I've got to say, since first semi-plan. Obviously, they're now part of the testing procedures you have to do. You have to verify that you're able to submit availability in a timely fashion, and there's much more focus on making sure that those are. Dynamic linear ramping is something that AEMO kind of insists was always there in the rules, but recently only they started producing graphs, and there has been some AER recent rule changes about how you should return to linear ramping, and I'll show you a graph on that in a second. And we're seeing increasing numbers of electrical dispatch constraints applying to plant that you have to cope with. So AEMO have put out this lovely new clarification graph. We did know about linear ramping. It sort of came up when we discussed FCAS cause of pays factors, that we were being evaluated against this imaginary linear ramp between your previous target, not your actual generation, and your present target. So there was obviously an implication there that you would follow a linear ramp, but not many plants did, to be quite frank. Now AEMO are insisting that that's what you're supposed to do. If your wind or solar, in the case of solar farms, resource drops, you're meant to return to your linear ramp that we've got there, which is an interesting point for some control systems. Some control systems aren't very smart that have been installed into, especially the older wind and solar farms. They're unable to calculate properly the right parameters and what the settings to support the linear ramping. So a lot of our systems have been implemented so that we can do them outside the control system and that we send those signals through to the control system. So what we've attempted to do with our, which we call our InfoLight product, is provide all of the things that we believe, and we've done this in consultation with a wide variety of clients over the years, of what do you need to actually run and make a profitable wind or solar farm. And so that we've taken that experience and we've built that into a product that we can actually roll out to any existing or new wind farm. So we're trying to incorporate a lot of things. We're giving you instant displays that enable you to know what your plant is doing at any time, information about the constraints that are currently binding and affecting your output. Also, an easy way of putting in submissions to AEMO, calculating things like the new dynamic ramping and handling things like element dispatch. So we have this diagram here which shows how the various systems interact. The AEMO sends the market data through. We provide a whole market database as part of our implementation. We have the interfaces to your SCADA system, and this is a separate interface than the little grey one up the top, which is your TNSP or DNSP. That is a controls type interface. And we also provide support for putting out the data to forecast providers, so that we fully support, especially not so much in the wind, but that's more in the solar realm. I'll talk about compliance here for a second. That grey DNSP, TNSP link is not where you're supposed to receive your market caps from AEMO. That is currently possible in some sites, but it is a non-compliant interface for providing dispatch caps. And compliance has been sort of given a bit of lip service in the market, in that a lot of systems, I would say probably of the independent solar and wind farms, I'd say more than 50% are non-compliant on this very point. And as we have seen from the experience of the South Australian blackout, that the fact that AEMO may not enforce a rule, such as voltage ride-throughs and those things, doesn't mean that if something happens to the electrical system and things go bad, that people don't come looking for you and putting in substantial fines. So we've seen in the public domain reports of $1 million sort of settlements and fines for those operators who didn't comply with that really obscure part of the connection agreement. And when things go wrong, the TNSP, DNSP link is one of those areas that AEMO does not regard as being 100% reliable, especially when there are system issues. So if you are not responding to your dispatch cap in a way that is believed to be compliant with the dispatch rules, and something is going wrong in the system, you could be held responsible and fined many, many times the cost of our entire, orders of magnitude more than our cost of our systems. So it's all very well when it all works nicely, but just the warning there that AEMO is aware that there is a lot of non-compliance in this area, and it's an area they would look very closely at. So our InfoLight system provides, and this is just the first tab of our InfoLight system, provides all the sorts of things you'd expect to see from a information point of view. And it can be, this system has a role-based authentication, so we can give access to different people like operators, traders, shareholders. We can provide access to some parts of the system to some users and some parts to others. But as it stands, this is sort of the front page that gives you a quick indication of what's happening to your wind farm. You can see on the left-hand side a map of the wind farm, and the darker the green, the higher the output of those turbines. You can also see, and unfortunately can't demonstrate this with a screenshot, if you hover over any of those other wind farms, they're wind farms that are in your location, and that's telling you if they're in red, they're being constrained, and telling you how much of their output they're being constrained to. If you hover your mouse over them, it'll tell you which wind farm's which. It doesn't leave you to work that out. Similarly, the FCAS prices we don't display, but rather is available to hover. And you can see that this has currently got a binding constraint. We can get information about that constraint by clicking on the Constraints tab and finding out who else is being constrained, what type of constraint it is, and we also provide the management reports that tell you which constraints were binding, and how much that resulted in loss generation. So there's a whole lot of non-visual elements of Infolight, and one of those is a comprehensive set of reports so that you can work out which turbines are working well and which ones aren't. It tells you things such as why you were constrained off, how much generation or revenue you've lost, and those sorts of reports. So that's sort of finding out how we run our wind farm. Now we move on to the section of how do we automate our trading and manage the financial losses that we can incur. As we pointed out in the previous PPA discussion, there's a number of different elements to that. There's negative price risk, which is an obvious one. A less obvious one is the fact that most generators are responsible to pay back the raised contingency costs, and that's a very difficult calculation to determine. And also there's that compliance risk, which we've already covered. In terms of PPAs, remember that a contract is a revenue agreement and an allocation of risk between parties. And it's that allocation of risk between parties that I think sometimes gets glossed over, because sometimes we can come up with arrangements, and Anthony pointed this out in the previous discussion about if you're paying the FCAS costs and you want to turn off, that might not be in the best interests of everybody. In terms of if you've got to pay them all, it makes a logical decision to turn off, but for both of you, you could come up with a better solution that benefits both parties. So what we have done is created a wind farm optimizing bidding solution. We do have other optimizers for battery projects, for combined portfolio projects and those things, but this one is just designed and dedicated to wind farms and solar farms. We also can put in all the quirks, and let's face it, there's a lot of creativity in the PPA contract writing business. So we can put in all those complications and if buts and when this happens and the solar eclipse or whatever. And we can put that into the revenue calculation so you have an accurate determination of whether you're making money or not. And it's fully customizable business rules. So we have this automated trading interface that just basically sits there, manages the process. We have a historical graph. Again, we can roll over with our mouse. That yellow section is when we turned off the plant due to probably price risk in that instance. And the red section in the timeline, we can see when we've been bidding for maximum revenue. This particular 5 minutes is when there is a high FCAS cost, and we're looking at the possibility there. We also alert the users when there are MII or OCD, which is overly constrained dispatch, or manifestly, I forget inputs, what is manifestly something inputs, MII, anyway. They're conditions where the prices may be revised at a later time. Just as an illustration of the point Anthony was making, if you have 100% fully contracted wind farm and the FCAS costs go high, it is in their interest to turn off, which is that top line. So we've got 100% PPA. This example is $60 PPA. The pool price is highly correlated to the FCAS raised contingency price, but because we're 100% contracted, we're indifferent basically to the pool price. So what we're seeing is that the logical thing for the optimizer to do, and this is a real case that we looked at for another client who actually was using a different approach than our optimizer. There was nothing wrong with the optimizer. It did the rational thing. It said the revenue was negative. It turned the plant off, therefore resulting in a lost revenue of $91,000. If, however, there was some sort of agreement between them that you wouldn't turn off in those circumstances and will compensate you for the FCAS costs, which is the bottom line, the generator would have made $500 And the PPA partner would have made, what is that, 91,000, oh, it fell off the side, $91,137. So the real problem here is probably the 100% contracted nature of the agreement. If there is some merchant component in the PPA, that means that the generator has some skin in the game, so that when the pool price goes high, they get some benefit from that. That will be a natural hedge for the FCAS costs, which usually are a much lower percentage of the total revenue. So I suppose the question there is, A, if you don't hedge 100%, there is that common goals that both parties have. If you do compensate 100%, maybe there is a scope for discussion, so there's a mutually beneficial way of responding to high FCAS costs that will result in greater revenue for both parties. So I'm suggesting that basically later agreement could be that the PPA partner agrees to compensate FCAS costs rather than turn off when the pool price goes high. Obviously, with an optimizer, it gives you the chance to make a revenue-based decision rather than a purely price decision. So in conclusion, the attempt InfoLight is basically focused to manage all of your renewable generator information technology needs from the perspective of trading, operating, and even information for management and shareholders. We have automated we've automated the dispatch process. We have alerting on various conditions. We have reports that sort of support that management aspect. And the attempt of the system is to reduce your financial and market risks. And we also take away a lot of the effort that needs to do to implement your own systems and things, in that we fully host these solutions and we fully support them, so that when there are issues with anything or just don't know what's going on, we are there to actually answer the phone. It also works with our other hard software optimizers, such as integration with our BESS storage units, and also with other systems as well, such as integrating in other forms of generation. So in conclusion, I'd just like to thank you for listening, and happy to take any questions. Oh. Okay. Okay, thank you.
I'd like to close off. I'll make sure it's quick. I'd like to start by thanking all the speakers, the moderators, those that were here and those that were far. I'd like to thank the organizers and Charlie on site, and those that could not make it because of COVID restrictions. I think for me, it was been a very interesting day. I hope that for everyone. I mean, cutting across a lot of different topics. One thing that for me was interesting was seeing the state. It almost felt like a bit of a competition. You know, everyone wants to do more on the show. They're doing this to us because we have good resources and we'll try and make it happen, which is, I think, great. There's no one state that doesn't want to do it. So I think that's an important, good sign. The fact that we're talking about a change of a pipeline of 80 gigawatts versus existing about 50 gigawatts. I think that number alone indicates how much of a transition it's going to be. And that draws to the different questions of the transmission limitations in different areas, and the fact that it's intermittent wind and solar and so on. So what we need more than that. The social license, I think that's a very important point, is we have an opportunity to do things now in a more integrated way, because we are talking about more land. So this could be more of a circular economy, and not just saying, I will put the plant there and this is what's going to happen. Because nowadays things can be harder if you don't have that social license. And of course, the PPA spot, it's a very dynamic pricing, and if we don't make things happen financially, that can be an issue. And it's this game of thinking long term, of course, the different aspects, but also making sure that in the near term, we're doing the right things to make sure that we're viable and the solutions are what we want. That's it from my perspective. Tomorrow, there'll be more, I think, more in the details of risk and optimizing the different aspects. This is more around the actual structuring, wind farms and wind turbines and optimization, so on. And for tonight, we will have, I'll invite Charlie in a second to to give us the details of the drinks. But I recommend go out, enjoy the last parts of the day, have a drink, talk to people, network, exchange ideas, and I'd like to wish you a very interesting day tomorrow. Thank you very much.
Hi, I'll be quick because I know I'm standing between you and drinks. Just a quick note, we actually have an exhibition area. If you haven't discovered that there's some exhibitioners who's offering their products and services that if you're interested, come and have a look. There's going to be drinks outside and a bit of canapes, and so feel free to mingle. I know like I mentioned this morning that it's been 2 years since we've done in-person kind of networking, so dust off those extrovert muscles and yeah, just enjoy yourself for this evening. And tomorrow we'll start at 9 a.m. I believe. So yeah, we'll see you then. And on behalf of Lead Associates, thank you for today.